check. Hello in the back. I'm trying to see if Matt's ready. Hey, Matt, you ready? Okay, hello everybody. Let's go ahead and get things started so we can run more or less on time. We'll do our best. Keep things going. So here we are again. Yay. So we're back. I got my sign up. It says "Hello Cleveland" because that's what you say when you're a Spinal Tap fan. And they did that. They come out and they go "Hello Cleveland," and they, of course, were not in Cleveland repeatedly. So we got that. But here we are in Nashville, and this is the first time that we've done a Southeastern Users Group meeting in Nashville that I'm aware of. We got a long history of Birmingham and Chattanooga. Those were places we've been to. A few others we'll put up, but we're back, and it's good to see everybody. And I appreciate y'all coming out, and I hope that this will be an opportunity for everybody to learn and interact with each other, and we'll get a lot out of this. So this is a good place for us to get together and talk. Just make it the most of it and try to, get to know each other, learn from each other. We are in Nashville. Nashville, this venue, and this is very nice. We have we'll have lunch over there, and we've got tables set up as we go through, so it's going to be a good setup for that. We've got some vendor exhibits out there. Schneider has got their new future, their software-defined architecture displays out there. They've got some things to show. Talsoft has a booth out there. They have some reporting packages and things that are interesting. And then we have, just for show, we've got the FDC 280. We've got the implicit Ethernet IP communication, and we've got that talking to an E300 and a PowerFlex drive from Allen Bradley, and those are out there on the table. We'll be doing a little short demo on that later in the thing. But that's kind of neat. That's something that's relatively new in the Foxborough world, so we'll be looking at that. We got a little bit of housekeeping. We have some Southwestern rules that I was told I'm supposed to go over with you guys. So here we are. All right, everybody has to come in through the atrium doors. That's where they've got a couple of, you probably picked up your badge there. There are a couple of guards sitting in the center of the atrium. If you leave through one of the other doors, you still have to come back through the atrium, so make sure you do that. And if you prop a door open more than 30 seconds, so set your timers, an alarm will go off on any of the other doors on the event center, so be aware of that. Let's be careful and not cause any problems. And if you are a smoker and you wish to smoke, they say you must do so by the flag poles. I think the flag poles are out that way from the atrium. I don't know because that's not something I've got to do, but be aware that they don't want any smoking by the side doors. So that's my thing. And now the emergency exits are right back here in the corner. So if there is an emergency, we'll all flee that way. And I don't believe there are any scheduled alarms for today for tests. So if there is an alarm, we'll all race out that way. Tonight, we have an event at Party Foul. Schneider has graciously agreed to pick up the tab for that. And that's a hot chicken and beer joint, and it's not very far from here. I don't know if they're going to have a shuttle from the hotel or not running. They were asking about that this morning, but we'll find ways to get over there. It's not very far, and I assume there will be a bachelorette party going there because we're in Nashville, and every time I'm here, there's just bachelorette parties going on. So we can see what's going on. We'll crash one. We got the chance to crash one last night at a barbecue joint, and Marcel and I were practically part of the party. It was great. Well, it's Groundhog Day again, as they say in the movie Groundhog Day. We're back, and a lot of you know each other. I know most of you, not everybody, and but it's here we are. We're back in another city and doing this, but we used to do this all over. We did them in Greenville, South Carolina. We've been to Atlanta a number of times. We were in Birmingham Waterworks for years because they would give us a free facility to do it at. So we've had a lot of those. And then Chattanooga for the last 3 or 4 years, and then now we're here. So, it's good to have everybody here. This is close for us. EOSys is headquartered over here in Smyrna, right down the street. And so it's kind of in, we're playing on our home field, so it's nice. Some things don't change. We're still mostly communicating everybody with the email list. That is, it's kind of funny because we've come full circle in all of that. Everybody was like, okay, this is antique technology. Nobody, you know, it's like, really, we're going to do this with an email list. And then AI started spamming, the bots started spamming everything else, but we have to approve all of the submissions on the list. We have moderators on it, so there's no AI spam on the email list. And so we've kind of come full circle, and people are like, oh, this is okay because we don't get a lot of email spam and things like that. It's very heavily moderated, works pretty good. A lot of the same people here. Just glad that y'all are here, and I'm hoping that we'll get some new people as we go. That's you know, the future. I was out last night with some young people from Schneider, and it was really interesting to get their perspectives on the future and what was going on. Obviously, it's a chance for us to get together and talk to each other. I'd say coffee debates, but we talk about you know, the good, the bad, things that we can do different, and I think we can all share some stuff there. And then, of course, this is your chance to talk to Thad and Marcel, who are from Schneider, and they're product managers back there, and are offer managers, and they have more influence on what's coming. And so I've been assured this year that they will be putting the .pnt parameter on the RIN block. Marcel told me last night at dinner, this is big news, and we're all very excited to see that happen. He is not going to do that. They said they will not ever do that as long as I'm around. So there you go. Talk about the email list. The email list that many of you are on. If you're not on the email list, you should get on it. It's Foxborough at freelist.org. If you go to freelist.org, you can get there. If you go to the CassandraProject.org, you can find a way to get there. If you see me and you're not on the email list, I can get you on the email list. We can take care of it. But last week, I pulled the stuff, and we had 1,055 confirmed emails on the list. So when you send an email, that's how many people it's going out to. And if we assume that 70% of the people are at least reading that, that puts you at a little over 700 Foxborough experts that are out there seeing these and responding to them. And then we have over 315 domains, unique domains. So that's people like, you know, EOSys, Schneider, Tronox, Alabama River, you know, the GP guys, and so that's how many companies you're pretty much talking to. You know, 700 people over 315 companies. So it's a very broad list. And then, of course, you can see we have like 46 Schneider email people subscribed to the list. We have 654 that are Gmail. I don't know where those people are. What, you know, I just get a name and a Gmail, so we don't know. But we have a lot of subscribers to that. Longevity is a thing. I found this in my garage, oddly enough, this week. 1998 and 1999 fell off of the plaque. They were there. I was there then. I didn't like disappear for 2 years and come back. But anyway, that was for being on the Foxborough IA Steering Committee. And I thought, wow, I've been doing that since '97. This is almost 30 years. It would be 30 years next year, and so that's crazy. I've been doing this a long, long time. I try not to have my identity tied up in this too much. I probably am okay with that. But then there's a fresh perspective too, and last night I was out with and I got called Unc, okay? Are you familiar with this? Because I'm not. I had to, okay? Unc is not good, okay? Unc is not good. Unc is like you're a geezer, you're an old timer. It's like, you know, and so I was like, really? And then that kind of hurt a little bit when you're, you know, when you're still as young as I am in my 60s. And so, man, Unc, and then I thought, well, she's really right. You know, I kind of am, and I got to deal with that. I got to have to do better. And so, but what was really funny was, does anybody know what the opposite of Unc is? Because I didn't know, because I said niece, nephew. No, the opposite of Unc is a little bro. So now I'm Unc and she's little bro, and that's how it's going to be. So we got that squared away, but it's different. And I think now this year, as I say, I'm like Unc, This year feels different, all right, to me, and it does. It doesn't feel different because we're in Nashville. It feels different because I'm seeing an awful lot of stuff happening that is been out there and it's been coming. We've seen this stuff coming for years, and we've been talking about it. This isn't like, we haven't just been ignoring it, right? AI is coming. It's coming. AI is coming. We've been saying that for 2-3 years. We've talked about it at this user meeting. And then this year, you're starting to see people really use AI for a lot of stuff. We're seeing people take the blocks, the calc blocks and stuff, put it in AI, back document things. We're seeing people use this just for helping with their system. It's not built into it, but they're going outside and using the tools. And we're seeing that a lot with the user group. Also, we've got a whole bunch of stuff going on with this software-defined architecture. This isn't just Schneider doing this. This is what we're seeing from all of the vendors. They're going to this idea of having the Docker containers. It's less than a virtual machine. They're virtualizing parts of a machine, putting them in containers, putting it in IT system stacks, like a on-premise cloud or whatever they call it, little set, and they're running this stuff that way. And those tools, those IT tools, and those ideas, the Docker containers and stuff, which we've seen for a while, are getting pushed down into the control system guys' stuff. So I'm seeing a lot of that now, and I think that's going to be a thing very shortly. In process control, they said the AI isn't hype. We did a little bit of research, and 80% of the process manufacturers are exploring or implementing AI on stuff. It's just going to be there. I don't think there's any way around it. That's happening. What does it do well? Well, it can do alarm rationalization and stuff like that. It does that pretty well if you feed it the data, if you have good data. If you have good data, which is critical in all of this, and that's going to become more and more important as you do these things, is you're going to have to get data that is scrubbed and clean and ready for being used in this. And then, so that's going to be a big part of it. The loop performance, all that stuff, very good at that. It analyzes, it does that well. What it doesn't do well is it doesn't do the parts of it that we're good at, right? Why doesn't something work? How is this supposed to work? What's wrong with this? It doesn't know that yet. It can't do that well. So, and it also doesn't know what it doesn't know, which is funny because you can ask a question and it will give you a very authoritative answer that is completely wrong, and you have to be aware that that is completely incorrect, and you got to get it out of there. So, but that's where we are. And there's a lot of things that we do that still matter, right? I mean, AI is not going to tune your loop if your transmitter's bad. It's not going to do the things like that. So you gotta know your plant. You got to understand your stuff. You have to have a lot of discipline and good plant hygiene in your system to keep it going. But it's coming. I'm interested here today in talking to everybody about what you see as the future. And I don't think, I think trying to predict the future is very bad. We're not good at it. It's hard to predict the future. I don't think we're going to. But I think we have an opportunity today in this room with the product offer managers and each other to influence. When you're not predicting the future, if you're creating it. And we have an opportunity to tell these gentlemen and each other, we think we should be going in this direction and actually have a little bit of say into where things are headed. So be thinking about what is it that we need, what is it that would make our jobs better, and how can we make it so that they have products that you want to buy. I mean, that's another part of this, right? They need to stay in business. You need them to stay in business. This is a two-way street, and if you can think of things that are going to help them, it'll ultimately help you. And I think that's it for me. In fact, I hit the time almost perfect on that, and we're going to let Thad and Marcel come up and present the roadmap, and this is going to be the Schneider Electric's path forward. And they'll be showing us some new stuff, and after they get done with that, we'll keep going. We have our agenda on the table. Feel free to look at that, and I hope we'll be asking some questions as we go. You guys ready? Okay. If you get one last thing as I walk off, if you get called Unc, all right, and you're using a Sun Microsystems mouse pad from the 90s, maybe you deserve it.
Hello. So we couldn't hear Dave in the back, and we kind of liked it that way. Can you hear me in the back okay, or do we need to do a little change of the volume a little bit? It's okay? It's better? Thank you, Unc. Thank you. Good morning, everyone. How many folks were in Chattanooga last year? Okay. How about New Orleans in October? Less than that. Okay. We showed some things in New Orleans that will be probably new to you today that we have to. I think we jammed it through the door yesterday and to get it going. But my name's Thad Frost. I've been part of, I'll say, Foxborough since 1992. So I think that makes 34 years. Used to work on micro IAs and Fox CAE and all that fun stuff. But I'm here with Marcel. We're going to go through the roadmap. A couple of things. I have my housekeeping things of my own here. You'd be surprised that we've already announced our automation days for this year. I did have 2025 in there, but that was a typo. It is 2026. It is going to be in San Antonio, Texas, August 5th and August 6th. And if you want to, if you want to raise your phone and just scan the QR code, you can get to the registration. But I'm pretty happy that we announced it this early, because typically we don't announce it this early. Typically we're like, oh, we've got a conference next week. But now we're giving you some notice here. The other thing that Dave already went over was the dinner tonight at the Party Fowl. It's starting at 5:30. I'm not sure how far it is from here, but 2.6 miles. I was going to say walkable, but a lot of people were surprised to see me, because I'm from Foxborough, Massachusetts. I don't know if you've been watching the news with the weather, and there's a lot of people were surprised to see me here today, because there was a part in Rhode Island that got 43 inches of snow. It's like something like that. But I came out of Maine, so I went all around it, because Maine didn't get hit as bad. So I made it finally, but it worked out. So that being said, roadmap, we get a lot of new faces, new management inside Schneider, and they all want to know, like, what's the big thing about the Foxborough DCS? What makes the Foxborough DCS special? Well, back in 2014, we were then in Vensis. We were acquired by Schneider, and Schneider has 160,000 employees worldwide. And Schneider does a lot. There's a lot in their portfolio, but the Foxborough DCS fit perfectly into the Schneider portfolio as far as the power side of things, the drive side of things. With we introduced EcoStruxure power and process, but at the end of the day, with Aviva, with Schneider, with Foxborough, with Ventus, the whole offering is quite broad, very broad. We think it's the most, the highest level offering that you can have. Also, through the years, we've had a lot of built-in reliability for the hardware on the hardware side, fault tolerance, redundant I/O, I/O modules that still run, and there's no failure on the 100 series I/O. That it's just the level of reliability has been very good. The thing that I think is why Foxborough DCS and why customers have stayed with Foxborough throughout the years is the last one, and that's our commitment to you. Basically around life cycle, not having to reprogram controllers, not having to rewire I/O, graphical conversion tools, so we can, for the most part, not push you into a corner or force you down a path you don't want to be, or force you to a rip and replace. And that's what we refer to as continuously, we used to refer to as continuously current. Now we can refer to it as future-proof, meaning it's an investment, and we're invested together in the future. I've also heard that we're good folks to work with at Schneider. And you'll see this commitment is that we have a continual investment into the Foxborough DCS, and we have a path forward from where we are today to future technology. So those are two things, right? We're investing in DCS, which you'll see a lot. You'll see we're investing in cybersecurity, device integration, software-defined automation, and you'll see that we have a path forward to these platforms and architectures. Okay? And this is just a visual of what I was talking about when I said that we fit into the Schneider portfolio quite well. Kind of plopped in there like a little puzzle piece that completed the picture. So what you'll see today, this morning, is I'm going to go through some of the hardware platform, and then Marcel's going to come back up. He's going to go through the software. We've got a remote speaker to talk about, what's that path forward to Foxborough SDA, or Foxborough Software Defined Automation. And then we'll also have a separate session after that to talk about FDSI. Within this roadmap, we pulled out anything around FDSI or FDC280 because we knew it was a longer discussion, and we wanted to give it some justice. So that's going to be after the break that we'll talk about that, okay? So if you're looking for FDSI stuff, it won't be till after the break. When we do a roadmap, we typically break it down between digital services, digital offers, cybersecurity, edge control hardware, and edge control software. The way we're going to structure it today is we're going to start off with the hardware. We're going to move to the software side of things. We're going to move to cybersecurity, and then we're going to get into the software side of things. You didn't start my timer. Okay, back in, as you know, for a Foxborough DCS, we have qualified hardware platforms, qualified virtual machines, qualified servers, qualified workstations. Back in October 2024, we released the Dell workstation. This is the 5860 tower. Its OS is Windows. It's a mouthful. Windows 10, IoT, Enterprise, LTSC. Okay. Typically, I finish ahead of time, and then Marcel takes it all. But yeah, this is, if we're looking at workstations, it's Dell. If we're looking at servers, it's HPE. This was released, the server was released in March of 2025. It is an HPE, what we call the Gen 11 server box. It's qualified with a Windows Server 2022 as its operating system. Its new model code is the H94. So this has been around close to a year. The thing I like is that you know, the virtualization box is basically the same. It's basically the same box. It's the Gen 11. It's also the same OS. There's just some modifications on it to, I'm not sure what those are modifications really, but it's the same piece of hardware that makes up the, whether it's a server or a virtual station. Also released at the same time frame. Also last year we had a new Thin client. We had a little bit of gap there in our offering with a Thin client, but we closed that gap really quickly. You know, so, for our Thin client. And one thing I really like is this is a really good visual about where we are as far as life cycle around the workstations, the virtual server, the VMs, the servers, and the Thin clients. Okay, so if you look at the first one, we talked about the workstation. The workstation be the D96. The OS, we talked about Windows 10. And the thing here that Marcel's going to talk about, anyone heard of CRA? Anyone know what CRA is? Interesting. Interesting. We're going to talk about CRA in the cybersecurity session. So we got the D96. We got the H94, which is also equivalent to the V95 for the virtual machine, which is the Gen 11 servers on Windows Server 2022. Now, if you look at look at the timeline, we've really done a better job than we have in the past around support, around being, you know, extending that preferred life cycle, and even extending that mature life cycle. So we're well into the 2030s. When you look at the support of both the Dell workstation and the HP servers. And same can be said for the Thin client. If you look at the preferred mature dates on those as well, we're getting a little squeeze there when it comes to doing the qualification on the Thin client, because it looks like we're going to have to be doing something in the next year or two on another Thin client. But well, I'll let Marcel talk about the new higher performance server looking or coming. The new Thin client, also these are the ones that we're going to be looking at, and he's also going to talk about the CRA assessment. So this is a good. I mean, you'll get these slides. This is probably from a visual point of view. This is a good spot where we're at with what we call the platform, or the computers, pretty much of where we are for qualification. Now, the same goes true with the switches. We've got a roadmap for switches as well. This goes back to 2022 and 2023. In 2022, releasing the high performance root switch. In 2023, the XIQ, or the network managing and monitoring. The edge switches came along a little later, 2023, the high performance edge switch. We added the Hirschman Greyhound industrial edge switch on Q1 of 2024. And then we did release a high temperature edge switch variant. So we have a bunch of different ones, but this is all encapsulated into also I guess we call swim lane point of view. There's the 5520 high performance root switch. You can see there that we're going to be, we're in the later stages of excuse me, preferred, but we do have a longer support window well into the 2030s. Same could be said for the edge switch 5420. you can see support into the 2030s as well. High temperature, high performance switch, again, up to 2030 for up into into the 2030s for support. And then the Belden industrial switches, another one that's got us past 2030 as well. Now, we will be doing some new qualification work, as we will be doing on the workstations and the servers. And these are just placeholders for where we're going to move, because it's like a constant battle, right? Qualify, make sure the life cycles overlap, try to extend that life cycle as much as we can. Okay, so in R&D in Foxborough, we just completed what we call a FCP 280 respin, where we're looking at components we may be running out of, or components we can't get on the market, and we've added new components to the FCP 280. Back in 2020, we introduced the enhanced online upgrade for the FCP 280. So those two factors basically mean that we've got the FCP 280 around for quite some time. If you notice the life cycle report, there's no end of life predicted yet for the FCP 280. And once you get to the 280, you keep it online. You don't have to take it offline to put in a new image. You can put new features. You can put new fixes. You can do this all online for the 280. Anyone running CPs less than 280s? About half. Less than 270s, or? Okay. What's that? So we got a mix of 270s and 280s. I would say hopefully you're planning on going to 280s at some point. Once you get to the 280, I think there's a lot of features that are there that from the enhanced upgrade, not having to reinitialize your sequence blocks or your accumulator blocks and things like that. So it's going to be an upgrade as far as that goes, from the 270 to the 280. But no CP60s, right? 100 series IO? Okay. How's that running? Oh, really? Oh, we do have a, I've been trying to sell you a 100 series to 200 series for about 10 years now, but we do have the 100 series to 200 series migration path where we can maintain that field wiring and take that nose cone and plop it right on a TAA and then electrically connect up to the 200 series. So that's still something I go to the Foxborough staging area and I see 100s to 200 series upgrades all the time. So we've done quite a few of those. Speaking of migration, one of the strengths of the Foxborough DCS is our ability to put our 200 series IO electronics into the form factor of the competition. Now you may have noticed that this list has gotten smaller since previous years. What we can still do in that form factor is the Bailey ABB system, the Net 90, the Infa 90, and we just recently did a new Honeywell TDC 3000, which is which in the Honeywell form factor with the Foxborough cards. What's unique about this is that we can pull out competitor cards, we can put our cards in, and we don't change the form factor. We don't change the footprint, and we don't have to touch the field wiring. We do have tools to do database work as well. So what it means is overall is that any downtime that you have would be minimized. The Honeywell one Actually, I say we just released it. It's I guess it's unk disease. You know, when I say we just released it, it's 2020 or 2026. A little bit of unk on my side. But this is putting 200 series in the Honeywell form factor. I think Joe, you're going to do something with this year, next year, this year, for Honeywell TDC 3000. It's going to give you the ability to do heart type signals into your I/O. It's also from a supply chain point of view, those the same components that are in our standard 200 series are in this card. So basically, we don't have to source different vendors, you know, capacitors, resistors, or chips or anything. It's all one pool of electronics. That's hopefully that makes you feel a little better about that. So okay. I like the timer, 23. Universal I/O. You know, during the supply chain crisis, this was an interesting phenomena that we had with the Universal I/O. This is our number one selling FBM during supply chain crisis, and we thought about it, and the reason is because it was a software-defined I/O module where you can channel per channel configure what you want to be on that I/O module. So channel 1, hard input; channel 2, digital output; channel 3, pulse; channel 4, DI drive. You can do that all from software, right? And what we found was that customers use this FBM to help basically prepare for the unknown. We know we had a supply chain crisis, and we know we faced longer lead times, but they know they wanted to do something, so they ordered this Universal I/O and just configured it later. So this helped minimize errors, reduce equipment costs, footprint, inventory. This is still a good seller for us. The Universal I/O has been around since 2011. Anyone use Universal I/O? Okay, a few, good. What we did after that was, okay, let's make it into a single part number, and we called this part number an intelligent enclosure, meaning you can just order one of these boxes, cabinets. We had a couple different sizes. We had an I-20 and an I-30. I-20 being for a field enclosure, and I-30 being for like more of a room. And so basically, you just order a cabinet. It's built up in Foxborough, and it's shipped out to you. We utilize some third-party vendors as well to do some signal conditioning, if you will. The Phoenix Contact, you can see there on the picture, the TA is a little bit different than a Foxborough TA, but basically allow you to use things like thermocouple converters, RTD converters, interposing relays, or you can just, those ones are probably just the pass-through. These exist both for Foxborough DCS and Tricon CX. So we have an SIE, which is a safety intelligent enclosure for Triconics, and we have an I-20 or I-30, which is an intelligent enclosure for Foxborough. Basically, it's supposed to help decouple your design from your installation. And you can deploy these as spare I/O. I mean, we have some major customers that keep one of these in their lab running all the time, or available all the time. And if they need I/O, they can deploy it and then order another one type of thing. Okay. Now, there's I mentioned a little bit that when Schneider acquired Invensys, it bolstered our portfolio. And as we started to integrate the two companies, we started thinking about how do we integrate power and process. So this is basically the hardware platform for power and process, and it's called the electrodynamic controller. And I think we've had it in some of these events here and there. Aviva Historian Roadmap, dismiss it. That might just create more questions than answers. So the electrodynamic controller, something that we released, I'll say fairly recently, although I may have UNC disease about that too. But it is basically a controller. It runs a limited set of the Foxborough blocks. Helps. It can control IEC 61850. Whether it's your medium voltage device, low voltage device, and basically bridging that gap between power and process. So I was going to ask for a raise of hands of one that's using this, but I think I know what I would see at this point. But anyone using this? Anyone interested in this? Maybe. What I get is sometimes a maybe. When I talk to people in different plants, they say, this is a vision for us somewhere down the line, but we got way too much to do right now. That's pretty much the standard answers. Like everyone's got so many objectives and different things that they're doing. But this is available today. Now, Edge IO for DCS. We recently released, and this isn't UNC disease, but we recently released in the last few months Edge IO for DCS. So Edge IO for DCS, I'm going to go to the last bullet there. It's not a replacement for the 200 series IO. It's not pushing 200 series IO away. It is more of a complementary offer to the 200 series IO. It also is universal IO. For some customers, it may be more cost effective, if you will. It is redundant. It is also software configurable. You can see all the different types of signals it does there on the screen. But it is a complementary offering to the 200 series IO. There is a box up there called the System Communication Module. Now, the System Communication Module is the intermediate module between FCP 280 and Edge IO. It's basically it's very, very similar to an FCM 2FX for remote IO. The other important thing that it does, maybe more important than actually the Edge IO itself to this group, is that this module, the System Communication Module, also talks to 200 series. So you can go FCP 280, SCM 200 series. And when you think about that, what it does is it provides you more flexibility for remote IO, because this is different than an FCM in the fact that you can do different configurations throughout it. You can have IO over here, daisy chain, star, quad, all kinds of different modes through that SCM. And what that provides is a really smooth migration path for the Z, I forget, I'm up north, the ZCP 270. Anyone have ZCP 270s? Aha, good. This, the 280 with SCMs and 200 series IO, this is a good migration path forward for the ZCP 270. and we can talk about some of this offline if you'd like, or I can get you more information offline on this. So I'll say cost effective, universal IO, probably better cabinet density, complementary to the 200 series. You can actually have a, the 280's got 4 drops off it, right? You could put a drop of edge off one and a drop of 200 series off another. But I think more importantly is that this is eventually it's going to be a replacement for the FCMs eventually. And then we will you can also use it with the 200 series today for we had customers standardize on single mode fiber, right? So that they wanted to use these for their single mode fiber. Okay. So, with that, I'd like to introduce my colleague. He may be a new face, familiar name. Between us, we have 70 years of experience on this product line, and I started 2 years ago. But this is my colleague and my friend, Marcel. Marcel.
Thank you, Thad, and hello, everyone. So to me, it's a little bit of an honor to be here. You have been eventually reading me on the Cassandra mailing list every now and then, but I never was in person showing up here on this group. So I remember times where people said like all wise and knowing list when they asked something, right, to the Cassandra list. So for those of you who don't know me, my name is Marcel Ramay. I am based in Germany, come out of Germany. I'm a German. I am since February 90 with the company, so a little bit longer than Thad, so 36 years now. I've worked 20 years on projects as a project engineer in Central Eastern Europe. So I did refineries, I did chemical plants, I did power stations and a pharmaceutical job. So did quite a lot of stuff in batch. And then after 20 years, I switched to a technical sales consultant role for Central Eastern Europe. So I was supporting sales with technical advice, with building designs for projects and helping with roadmap presentations and so on. And since 2018, I'm in the global role as the offer manager for control software. So I'm a colleague of that, looking after the software in the system. So we switch a little bit gears now from hardware to software. And as you know, cybersecurity is on everyone's agenda these days. And I felt this would be worth having a couple slides that focus on this topic specifically before we start into the software topic. So first of all, on a high level, and you will know this, right? But I want to emphasize, this is not about products or about software or about a solution, right? Cybersecurity is really about the working together of people, processes, and technology. So it involves changing procedures. It involves establishing processes. It involves changing the technology. And it's a journey that never ends, right? So you're not done if you buy this firewall, or if you buy this domain controller, or if you implement this lockdown, whatever. It is a journey that is holistically looking at all the elements that drive this. And one of the bigger elements that we use to demonstrate this is certification. And as a company, we have been committing to the ISA 62443 standard as the base for what we do. And we certify our solutions based on 3 different dimensions. One is the component level certification, which is called the Embedded Device Security Assurance, EDSA. One is the life cycle that we follow to actually design and build a product. And this is called the Secure Development Lifecycle Assurance, SDLA. And the third one is a reference architecture where we document how to build a secure system that you as a customer could refer to, saying, if you build your system, if we build together your system following this reference architecture, we can claim that we comply to this SSA certificate. And we were the first ones in the market that applied to all those 3 different dimensions at the same time. In the meantime, our vendors have applied as well, and the standards have evolved. You will get the slides, you will see the links. They are from the ISA Secure website, and you can download those documents from there. Right, so this is the SSA Level 1 certificate, and we are working on a Level 2 certification expected to be available by the end of this year. Now, there's a new kid on the block that's called Cyber Resilience Act, and it is from the European Union, and you might say, well, who cares, right? It's not something that applies to me, as I'm not part of the European Union. But the difficulty for us as a vendor who's selling global to global customers, where many of our global customers have headquarters in the European Union, is that this law is very relevant as it becomes mandatory for everyone who wants to sell anything digital into the European Union after December 11th, 27. We come to that. And as we are a global company selling to global customers, and many of our global customers have their headquarters in some country in the European Union, and as the European Union has assigned compliance to the CE mark, which is what we put on every product that we sell, and which, by the way, many countries and industrial societies request as a sign of electromagnetic compliance and other high-level regulations, right? We made a decision a year ago that we will not build products that are and are not compliant, so 2 groups of products, right? We have made a strategic decision that everything we do will be compliant to the CRA regulations. And you see here what is the requirement and how we comply as a vendor. What does that mean to you as a user? I'm not going to read all the details, but you get the slides again afterwards. So the timeline is critical because the law is already in effect, but right now it is an optional element. So people can choose to comply or not to comply. By September 11th this year, so in half a year, there is a rule in force that actually forces users of digital equipment in the European Union to enable reporting structures to government authorities for known and detected malware incidents. That means several things. One is your products need to be able to report incidents, but you as a user, you also have to have a team and infrastructure in place to be able to recognize, to consolidate all those reports, and to be able to respond to an inquiry of an authority if and to what extent your digital infrastructure has been attacked. And this comes into play in September this year. And then in December this year, we expect a revision of the ISO 62443 standard that is harmonized with the CRA law, which means it is aligned to cover the gray zones that are currently not covered well between those 2 language texts, right? So between the law and the standard. So the harmonized standard essentially means that everyone is following the 62443 standard is affected by the law, even if you're not making a business in the European Union. So that's another aspect also from the user's side, that CRA is relevant to everyone in the globe, more or less, when it comes to digital equipment in the global industry. And in December 11th, there is the mandatory deadline, which essentially says any product that sells into European Union, which is of digital nature, has to comply. And to be precise, it means it has to comply in its default behavior that comes out of the box. That essentially means we can build a product that can be configured as an optional behavior to not comply, as long as it complies with the default behavior. And this will become very relevant to existing users of our products, because compliance means that everything is encrypted, everything is authenticated and authorized, right? So authenticated means that we know who is acting, and authorized means that when we know who's acting, what is the exact right of that individual or daemon or service who is acting. And encryption obviously means we have to have means in a way that protect the integrity and the consistency of every digital communication in the system. Right? This means everything between CPs, and workstations, everything between an engineering workstation and a CP, And you can imagine if you have a system that is already running, that has not been designed to encrypt all this, and you add elements that encrypt, it will stop working. Right? So this is a critical thing that will affect us all, and it drives a lot of the investments that we're currently doing, which means this becomes relevant to all of us. This is what we do. I'm not going to read this. A lot of these things that we are doing make a lot of sense, so they are common sense. So it's super important that we do not understand such a law as a nuisance or as an annoyance or as a burden or a pain. It is really making everything that communicates in a digital fashion more secure. That helps with availability, that helps with confidentiality, that helps with protecting your production assets, right? And everyone who follows the news sees reports of cyber attacks costing a lot of money and costing production uptime. So this is all valid methods and valid things that we as an industry need to do all together. So I want to make sure that everyone understands this makes sense, and it is not just, you know, something that's put on us against our will. There is different steps on the security levels that we strive certifications for, and this applies to the SSA certificate, the Secure System Assurance. So we currently have the SSA level 1 certificate. We look at certifying SSL level 2. And anything beyond level 2 means that we have to have full encryption in place and full authentication authorization in place, which is what we look at for the future generation of our product, which we call Foxborough SDA. And you'll hear about that in the next session after this one. And you can see first glimpse on the demo that we have brought with us in the lobby. So please ask us questions when we are on the break. Thank you, Christian. We are available for you to explain to you what we have been building and what you can see there as a first glance. So our roadmap in a nutshell is really to understand the gaps, build this SL2 compliance certificate until end of this year, build a list of things we want to do next year, and then fix those gaps until December next year, December 27, where there's the deadline. And the goal is that our offer is CRA compliant. So with that being said, let me dive into software on a very high level. You will see very busy slides, and I want to finish a little bit early so that we have time for Q&A. And of course, I'll be here today, tomorrow, together with Thad. We are at the demo, and we have a Q&A session at the wrap-up in the end. So there will be plenty of opportunities, hopefully, to come into a conversation. Before we start into software, I want to make sure that we all understand the terms, the terminology. So you know our solutions since many, many years as the IA series system, the intelligent automation system. And in the past, we never changed the underlying paradigms of the product, right? So this means the namespace, the runtime execution paradigm, the blocks, right? So this all has been brought forward. While we switched all the platforms that we run our products on, we have never touched the execution and runtime paradigms of the overall technology, which essentially would allow coexistence and collaboration across different generations of the product, which allow our customers to migrate smoothly at their speed, their budget, and their schedule. At some point in 2006, we integrated with a company called Wonderware, now called Aviva, that have been put together with Foxborough to form Invensys, and you know all this. And back in the days, we have been asked, how can we leverage the offers from Wonderware and Foxborough together to avoid double development of very common things like an HMI, like a configuration environment, like a historian. And we essentially declared the Control HMI, which is a flavor of Managed InTouch from Wonderware, now in Aviva, and the Orchestra Galaxy, which is the configuration environment for the system platform from Aviva. And of course, the app server and other elements. We declared this to be the preferred product for the Foxborough DCS, while we still maintain the existing environments like ICC, AIM-Star Historian, and FoxView alive and kicking going forward. And you know all this, you run your plants with a mix of those, and we still support both generations, and we just want to make sure that we are clear here on the terminology, right? When we say controlled software, this is the summary of control editors, Control HMI, the Aviva Historian, and the app server. And when we talk about legacy apps, we are referring to ICC, AimStar, Historian, FoxView, and everything is alive and kicking as we speak. For FoxView to Control HMI, there is a migration path. It is actually a delicate thing because both solutions have been developed historically independent, and the concepts and the data structures and the way the HMIs are actually rendered and animated is super different. So there's no single obvious conversion philosophy possible. What we have today is a software solution that helps with 80% of the simple statics and dynamics, and then it delivers a precise list of things that it couldn't convert, and we have to do an engineering effort to fill those gaps. We are starting an initiative as we speak. We call them OTM. There are risk and feasibility determination processes that we do before we actually start a project within R&D. So we start an OTM on how can we better build a migration concept that also helps with our future system, FoxPro SDA, that we talk about in a minute, so that we can build a more holistic migration approach. Until then, it's perfectly fine to stay with FoxView as you are, but you need to be aware that FoxView is in an available life cycle, which essentially means we keep it alive, but we don't innovate into this product anymore. The innovation happens in our latest and preferred product that's in the preferred lifecycle, which is Control HMI. The benefit of migrating essentially is that we jump on a technology called orchestral graphics or industrial graphics, which is the base for all the future HMI solutions that we will deliver in the next 10 to 15 years. So if you migrate, you might eventually end up with something that's very similar to what you have today in terms of what the operator sees and what the operator experiences, which is good because operators don't like changes, right? Don't like disruptions. But it will bring you on a technology stack that's ready for the future, and this is the inherent value. So if you plan to run your plan for the next 10 or 15 years, possibly, then migrating is something that would get you prepared for being ready for that future. Now, if some of you eventually are aware of Aviva's HMI products, you have noticed that with our system platform 2017, so quite some years ago, Aviva is introduced InTouch OMI, that stands for Operations Management Interface, as the future HMI. And there's many features in OMI that is very appealing. It's fully web-based. It's fully dynamic in terms of screen size. It works on phones, tablets, PCs, and large screens alike. It has interesting integration options. You can introduce video feeds, web apps, and other elements from dashboard. It's all dynamic, like in terms of zoom level. You can zoom in and out seamlessly. If you have a touch device, you can zoom like on an iPad or your phone. It's pretty cool. But we don't use this for the FoxPro DCS, and the question is why? There's a simple reason. As one central element of OMI is context awareness, which needs a hierarchical asset ontology to be used as a reference. Think of it like you have a hierarchical model of your plant. The operator points to a point in this hierarchy, and the HMI renders whatever is relevant at this point in the hierarchy, right? And FoxView doesn't know that. FoxView is dumb. It shows a list of graphical elements that have been animated with compound block parameter, and there's no such thing like a hierarchy. There's no such thing like context awareness. So very nice things like alarm aggregation based on the context in the plant, or a relevance of information based on the job of the operator. All those things don't work with a system that is not hierarchy aware or context aware. And that's what OMI delivers, but the DCS doesn't have this ontology. But there's no bad news without good news. Our future offer, the FoxPro SDA, is based on a hierarchical naming concept that delivers this ontology, which allows InTouch OMI to be used, and this is what we actually do. So if we look into the future of the Foxborough DCS, which is called Foxborough Software-Defined Automation, and we come to that again next presentation, this is fully enabled for InTouch OMI, right? So we made a conscious decision to make these new features available where it makes sense technologically. And it's not like we decided, oh, it's a marketing decision and we want to push people, right? It makes technologically sense to have this context availability and context awareness available to deploy InTouch OMI. And clearly AVEVA positions OMI as the future of the HMI technology going forward. So if I, as an offer manager, have to design a product future that goes on 10 or 15 years, this is the way to go. Some of you might have heard of things like silent install or rapid system deployment. This is, in a nutshell, a thing that allows to install a system in a scripted fashion. We don't have to babysit, the process to swap DVDs and wait for a response and click on buttons. We can script the install and it all runs in the background. And we've released this with 9.5 for day 0 installs as a phase 1 product, which is what you normally don't see because this happens in our checkout facilities and our service people use it. But now with the latest release in 9.9, which we just released end of last year, we introduced phase 2 of this rapid deployment feature, which covers day 1 automated installs. And this was because customers were complaining that on very large systems, they need a week to actually do a committed install with all the work permits and all the challenges that come with large geographically diverse plants. And with that, you don't have to physically go to each computer. You don't have to physically shut down a machine. You can ask for a permission to remote upgrade a workstation, and then it runs fully in a remote fashion. Field Device Expert is always on our radar. This is the embedded digital configurator and maintenance environment for a fleet of thousands of digitized field devices. We've been recently introducing all kinds of new features that help with deployment, with condition monitoring, with health and status reporting, and it allows snapshots that can be used for very easy device swapping. So if you have a digital device and you have to swap it, you just replace the device and it comes out of the box, you deploy the last snapshot and you get it online and it just works without having you to figure out how this configuration actually now works. Pretty cool environment. We are working on several enhancements, and one of them is not listed here because it's a thing we are currently internally planning for, is support for a calibration management solution that will help managing the digital calibration records of a fleet of digital field devices as part of the system. We talked about EcoStruxure Power and Process. And I'm skipping all these slides a little bit because I was seeing that there's not a lot of coverage and interest in this group. In a nutshell, this is the idea of combining power management, so energy management and process automation together in a live fashion so that operators have one pane of glass to look at one range of variables that come from either side of the fence. We have one common alarm list, we have one common time base, and you can do a first off analysis, a sequence of event analysis of trip reports from the energy side and of process alarms on the process side. And if you apply automation on top of this link, you could eventually drive your plant with degrees of freedom so that it's driving the energy consumption in a preferable fashion when you have dynamic energy prices. If you depend on market price for electrical energy, for example, you can help the company make more profit with using less energy on high price times and using more energy on low price times and using capacities of your plant to actually accommodate for those dynamics. And there's a process that does this. We released this with Control Core Service 9.7 and it's available to be used. This is a thing we call the states view. It is an energy management view on energy management devices. That is a dynamic, filterable, sortable list of tags from the energy side. And think of it like an Excel list with a dynamic hierarchical structure where you can click on elements and it opens a detail pane on the right side. And you can watch into switches, transformers, and other low voltage medium devices that are connected to the energy management piece within the process automation system within Control HMI. We released in February 24 the last version 9.8, which was the first version on the new generation of operating systems that we qualified back in the days, which is Windows 10 LTSC 2021 and Server 2022. From Microsoft, we produced OS kits for existing computers to bring the computers up to that level. And we brought all the underlying software forward except IACC. Is there anyone using IACC here these days? You don't need to be shy. Happens in the best families. So very good that I see no hands coming up, because this is a product that's definitely end of life. So we will stop selling this in October this year, and support will end very soon after. And there's many conceptual issues with this. We decided to not bring it forward for the upcoming software releases. Now, as this is eventually relevant, let's zoom in a little bit on the Microsoft Windows operating system timelines. So you see here a lot of bars. Each of the bar is representing a Microsoft generation of operating systems, right? So it's always a combination of server and workstation operating systems. The green ones are the ones we chose to qualify, and the reddish ones, red rows, right? These are the ones we chose to not qualify. We are where the today bar indicates today. So we are on Windows 10 IoT 2021 and on Windows Server 2022. And the next thing following our tradition to minimize disruptions for our users would be to skip the next version, right? The yellow one. But as the Cyber Resilience Act is coming, and as Microsoft has declared the Server 2025 generation of operating systems being the first OS version that is CRA compliant, and as the next long-term service generation of operating systems is possibly expected to be coming in 27-ish, end of 27, this is way too late for us to actually turn this into a qualified product until December 27. So with that reasoning, I would say possibly decided, because it's not finally decided, but I see 29% coming. We will change our habit and we will jump on Windows Server 2025 possibly next year. So I want everyone to be mentally prepared, right? If you're on an older system, like 2016, which is what many users currently having, this is end of extended support in October 26 for the workstation and January 27 for the server. So that's very soon. And then we still don't know if the extended security update program for Microsoft will be released. If it will be, we will apply and we will make it available for our users. But it's an expensive program. It's really more a fine, a penalty that Microsoft charges for users that didn't update, right? So we want to position this as a last resort option, but not as a recommended way forward to avoid upgrading, because this fee accumulates over the years. Last programs extended over 3 years, and the price was doubling every year, so it added up to a ridiculous amount. So our plan is, and it's 99% sure but not confirmed, to have the next or the version after the next, that's one of the elements that's uncertain, to be on a new generation of operating systems which is 2025. The good news is that this system OS is not so much different from the latest version that we currently have, so the disruption will eventually be minor. But as it will introduce encryption everywhere, this might have a consequence. And we did an early test, and it broke a lot of things, right? So it's a bigger thing that we are planning for. All right, we released with version 8 in February 2024 a major upgrade to our system, where we literally didn't leave any stone unturned, right? So we changed the underlying software stacks, we changed the operating system, we changed the compiler that we use, skipped 12 years of generations for the Visio Studio compilers. We changed the Office packages, Visio and Excel. We changed the SQL Server, and we did all kinds of stuff behind the scenes to enhance security. We reduced things that need an administrative right as an operator role. that helps with security. And we tried to benefit from additional values of the Aviva system platform. We adopted a new graphical skin for the configurators, and all kind of stuff happened behind the scenes. So this was a big, big upgrade. And it came with Control Core Services 9.8, which is on the next slide. It also received, no, it's on one of the previous slides, I guess. We fixed a security issue that was mentioned by Aviva in this vulnerability below. We have seen customers asking for this. So if you're interested in fixing that, the only way is to upgrade to Control Software 8. And we also brought up all the, we call them independent apps, which are applications that are not part of the system, but which are around the system, if you will. So that are things like a configurator for the FTSI, the centralized virtualization management software, a configurator for the FTC 280 and FTC 280 drivers and other stuff. So all of this has been updated as of today. The yellow elements are not part of the corporate portfolio development, so that is delivered as engineered solutions from other teams, but also those teams have in the meantime upgraded their solutions. Right, so Fox CTS, for example, Fox Page, Fox Bridge, these are solutions from our Houston engineering team, and they did all the upgrades required. But they're not in our control, so that's why I'm not mentioning them explicitly here. We also built 2 maintenance packs for the previous version of software, which is Control Software 7.5 to be precise. And we are considering to deliver a last upgrade for this software in summer this year. And this is the Server 2016 based generation of software. The sales is actually going down quite a lot. We sell like 5% of the overall sales on this software right now. So it is an end-of-life product, which means it is end of extended support from the Microsoft platforms underneath in October this year. So we really can't position this as a recommended product to go for. So it's an available life cycle. We keep it in available as long as we possibly can to help customers in completing existing projects and minimizing disruptions. But clearly, if you have a degree of freedom to choose, the advice would be clearly to go on a product that is on a current OS, because we fixed so many things in there. And it's highly likely that if there is a new defect coming up on those older versions, that we will not backport this fix from a newer version to the older version, because we just can't sell it for long enough to justify the effort. We have also introduced a new licensing scheme, and the salespeople always try to prevent me from showing this slide, as of course all the commercial discussions, discounts and pricing is owned by the local sales teams and not by a global portfolio offer managers. But we've changed the philosophy how we position the order price development from local teams from the global factory in a way that we honor all previously purchased licenses as being eligible for upgrade discounts. And also, so this is also eligible for our local teams, which means if you have, for example, if you have a vintage Informix historian, or if you have an AIMSTAR historian and you want to upgrade to the latest Aviva historian, then we don't say anymore, oh, this is a new software, you have to buy a new license, right? That was the previous statement. If you switch software generations, if you switch from Foxy to Control, you have to rebuy the software. And this was a pain, right? Because it limited the availability for discount conversations for our salespeople. It had all kinds of challenges on the way. We changed that. So we say now, if you have a functionally equivalent previous software running and you purchase that with us, you are eligible for discounts. And the level of discount depends on if you are maintaining a customer first maintenance agreement, any size, any variant, allows you to get a first level of discount. And then there's a specific level that is called software version entitlement included, which is pricey, I agree. But this essentially means that you get all the upgrades of functional similar software at no additional charge. It's covered by the contract. So we designed this to give maintenance agreements additional value for everyone to stay current, and the challenge of staying current will be an increasing challenge going forward, mainly for cybersecurity reasons. So if you're interested in any details, please work with your local sales teams. This is just to share with you that we made it easier for everyone to fund an upgrade, we are not asking anyone anymore to repay the whole license as new. We released Control Software 8.01 in October 24 already. So again, we're already in 26. So this introduced batch management for the DCS, no change on the underlying versions. This is important for pharmaceutical plants and life science plants. And then we introduced a brand new product that's called the OPC-UA server. So this says many things. One is we still innovate and invest into new technology in the FoxPro DCS. So I hear people like, oh, this system is around like 87, and this is like dead, right? So nothing new happens there. Why even look at it? And we commit to this in a way that we add functionality to it that enables a collaboration and coexistence with a future system that we are talking about on the next presentation. And the OPC-UA server is a core element here, which enables secure communication in an industrial standard to OPC-UA clients across the board. And it completes the offer because we already do have an OPC-UA client driver for the FDC 280 available. So we connect to servers and clients alike. We released this in a first version in March 2025, so a year ago. And we are currently working on delivering a redundant flavor of it. So it delivers non-transparent hot A redundancy. This is a term from the OPC-UA standard, which essentially means that both servers that are redundant deliver the exact same information in real time, and the clients can just flip over from server A to server B as they want. We implement, so you could say, why the OPC-UA server? There's OPC-UA servers out there, right? So there are servers from Kepware and from Unified Automation. Why can't we use those? And our response is, we built this OPC-UA server to be a good citizen in any FoxPro DCS. So first of all, it's Aviva software free, so it works with any system out there, right? With or without controlled software. It integrates natively into Object Manager. For those of you who are deep into the system, Object Manager is the legacy real-time namespace manager, communication manager within the FoxPro DCS. It integrates natively in there for read and write operations. It is aware of system configuration. It knows which CPs you're having and which type of CPs you're having. It tries to minimize load, additional load that's put on the system from clients to your older CPs. So as an example, if an OPC-UA client connects and says, give me all your namespace, browse star.star, right? The OPC-UA server would try to get this information from every participant in the network, and this would flood the network with broadcast requests and would overload the CPs. And our OPC-UA server is aware of the system configuration, is aware about the CP types, does know the idle time of the CPs, and it throttles the load that's been put on the system from external clients to actually ensure that the CPs can stay safe and can operate and can run their critical tasks, which is running the process and serving HMIs. We have introduced several dimensions of this protection. In a nutshell, it protects the system against malfunctioning or misconfigured clients, and they are patent pending. And I'm actually very proud that I am one of the patent holders of those. So if the patent is pending, you can consider me a patent holder for Schneider Electric. We have applied. I've heard that it might need a couple of years to get approved. We'll see. Control Software 8.1 is just released, so literally a couple of weeks ago, which is based on a new Aviva system platform, which documents, again, we stay current, we stay close to Aviva's developments. This is the last version we'll deliver on 2023 of this product, and we'll jump on System Platform 2026 with the next version, and Aviva declares this as being the first version that's CRA compliant. So again, we try to stay on top of cybersecurity and to deliver to the promise that by the end of December 27, we are CRA compliant. Here we updated, again, infrastructure like SQL Server, Excel and Visio. We replaced a binary formatter that's an internal function that we use from Microsoft that had a known vulnerability that was a bit of a challenge to change. We adopted Aviva changes. We did a full regression test on the full range of products, so it's a full release of the whole system. We introduced InTouch Access Anywhere, which is a HTML5 web-based access to the Foxborough DCS, right, as a fully supported product. So that would enable a remote access to the Foxborough DCS without having to put any client, any system software on the client. You can use any HTML browser like Google Chrome or whatever, a tablet, and connect to the system from any distance over the internet, over a secure link, and then fully operate your system. We introduced with that version also Control Core Services 9.9, which is the latest version for the Aviva free version of our system. Again, introducing Rapid Deployment Phase 2, which supports day one installs. We finally support Edge IO for DCS, which we show on the demo outside. And it brought official support of Engineered Solutions with the SEUG software that we brought into the system with a high-speed data integration server for those people who are looking at millisecond precise synchronization of digital inputs to do a first event analysis. Now, with that, we are in the presence, and where are we in terms of future? So what is next? And I only have a very few couple slides because we have a separate presentation on that, right? So first of all, the overall roadmap that we are looking at. So we are currently looking at 2 lines. The top line is the Aviva software development for control software. The bottom line is what we as Foxborough do with the Foxborough DCS. So you see the control software version 8, version 8.01 versions that we released in 2024, which brought a new version of the license, which we call FX version 2 license. In the background of these is that Aviva changed to a new licensing mechanism with latest versions of system platform that enforces version compatibility. So that means the Aviva license only enables software that matches the license file. And with every new version of system platform, we need to get new license files. That puts some challenges on us because every license upgrade is an effort, right? But we made this as easy to digest as possible. So when we started with 2023, we call the control software version 8.1, and 8.1 is a no-charge upgrade against 8.0, right? The rule is if the number doesn't change before the dot, it's a no-charge upgrade. If the number changes before the dot, so from 7 to 8, we ask you for an upgrade fee. And again, there's rules for that, depending on if you have a customer first agreement or if you have the software entitlement option included. Speak with your service or sales representative to determine the exact situation. We built a specific manual process if you're on historic licensing. So if you're on previous licensing for the IS series in the 90s or 2000s, if you're on S56, 7, 8, for example, license codes, or if you're even on older paper license code, right? Whatever entitlement you have, we find a solution and we actually respect all previous entitlement. So looking into the future, we look at deploying Aviva System Platform 2026, which is the first CRA compliant version. And this translates into Foxborough DCS Control Software 8.2. And this will need a new license as well, which is the V4 license. We plan for this end of this year. And we see if we get there, because we currently have some discussions going on prioritization of other stuff. But this is our current plan, but it's not committed yet, so which is why you see a question mark there. But this is not the CRA compliant version yet, because this will only use CRA compliant software for the software stack that we use, but we have to do some homework as well on our end. And most probably we will use the new operating system from Microsoft in 8.3, so the version after. So Aviva is planning to release a 2026 R2 version. It's not R question mark, it's R2. Possibly end of this year or early next year. And then our goal is to deliver a CRA compliant Foxborough DCS version with which we call 8.3 by Q4 next year, so 27. And this will then have most probably a new version of licensing as well. And again, as long as you don't increase the number before the dot of the version, It's a no-charge upgrade. So if you have an 8.0 system, you want to upgrade to 8.1, 8.2, or 8.3 in the future, work with your salesperson. We make sure that you get the new license files at a so it's a no charge for the license, but we charge you $150 per line item to cover the manual effort of processing the generation of the new files. But it's not a new license fee, right? It's really the stuff to you guys. With that, I'm more or less at the end of my prepared slides. So we now prepare for the next session, which shows where we are in 15 years from now. So it really elevates our thinking a little bit wider. And for that, we will welcome my boss and our colleague, so also Thad's boss, Baljit Growell. He will join us from Montreal, Canada, in a remote fashion. And I would suggest, if this is okay, to have everyone eventually a little break, a little coffee zip, if you need a bio break, to take a breath, digest what you have been hearing, and we gather again at 1:45. That was what was written on the agenda. Does that make sense? Very good.
introduction of a man. That we have available today with SDA, and then we're going to talk about the convergence program, and that's how our large Foxborough install base converges with Foxborough SDA. And then we'll talk about some use cases as to how you can start using SDA today. So, moving rapidly on, right? Originally in 1987, right, the IA series was one of the first open intelligent automation systems. That concept of being open has been held quite dear to us over the last 38 years. One of the key principles of the Foxborough DCS future architecture is to enable open software-defined automation. And I've highlighted the word open, and we'll talk about that in the coming slides. We understand that the industry and our users are requesting that we drive towards remote and autonomous operation, but at the same time, we want to have advanced system management, we want self-diagnosis, we want self-healing, we want to simplify and automate system setup and software deployment, right? At the same time, wherever possible, right, we want to create the system configuration from the design so that we bypass that configuration step. We also have a significant number of our users who are part of open industry standard forums like the Open Process Automation Forum, OPAF, NAMUR in Europe, and also Universal Automation, right? So having that open and interoperable system is part of our future architecture. And then as apps like we have on our phones proliferate more widely into the operating technology, IoT systems, right? We are committed to providing compliance for edge apps within the system. So a number of key architectural changes that we're making, right? And these have significant enablers. So obviously we need to be have always had cybersecurity by design, right? So right from the inception of a product all the way through to delivery, right? Being cybersecure has always been a key fundamental requirement, and that will not change, right? Adopting industry standards, decoupling software from hardware, again, is a key tenet, right? So that we try and break some of the obsolescence issues that we've had in the past and continue to have. Recognizing that not only will we have control, like we've had in our controllers for many, many years, but we will also have compute applications running very close and in parallel or next to the control application. So control and compute, right? And having platforms that are scalable, right? Not just one size, but something that can be small and scale as you grow or as you change your architectures, right? We also recognize that the number of sensors that we have, right, and the types of sensors that we have is also changing, right? So as we have had 4 to 20 and then we moved to other I/O buses, Foundation Field Bus or now AP or other internet-based protocols, we also have a huge number of wireless sensors that are already available, and integrating them is a key aspect. So we want to ensure that all of this sensory information is available, right, to the system, to yourselves, to your business partners, so that we have the simplest path to data, right? We have a single source of truth, and we remove the significant we spend at the moment manipulating data, making that data available, right? So some very core principles for the future architecture. So let's just look at what do we mean by open software defined automation. We have four pillars, right? Hardware independence is the first. Um, so the freedom to choose the hardware that you wish to use. And that could be workstation hardware, that could be control platforms, that could be network switches, right? So the freedom to choose the hardware that you would like to use and eliminate that obsolescence problem, right? Distributed intelligence, so the ability to run control, right, where it makes sense. So we run control at ladder logic in IO modules at the moment, right? And we run control in the field in positioners. If you look at validation field bus, for example, we run control in our controllers, right? As the architecture changes, right, we have more options, right, where you can run control. And that control location and that compute location will really be driven by your determinism requirements, your latency requirements, your privacy requirements. So there will be choices that you can make as you upgrade and reimagine your systems. And then being application centric, right? Focus your architecture on what is the purpose of your plant, what are you doing with the control? And then digital continuity, right? A lot has been said about IT/OT integration for many years, right? And really, this is one of the key pillars where we want to make that data available to you as quickly as possible and without manipulation, so that you can action it, you can analyze it without all of the significant effort that we currently put into this. And all of this is uniquely delivered by Foxborough Software Defined Automation, or Foxborough SDA. In terms of our architecture, and what I'm showing you here, right, you can see elements of this in the demo stand outside of the meeting room. So I'm just going to talk quickly through what we have here with respect to the various components. So, of course, we will have field devices, right, and this will be different types of sensors. We can have our traditional 420, we can have wireless, we can have Bluetooth, many different sensors. And then we have a number of systems, right? So you'll recognize that we will continue to support the 200 series standard and compact I/O family with Foxborough SDA, and there will be a specific what we're calling an edge communication node that will allow you to connect your I/O to the network or to a controller. So some of the architectural changes that will be open to you, right? We will continue to be able to integrate and allow the direct connection of packaged PLCs and other subsystems directly to the control network. So where we've in the past and currently say that the mesh control network, the Foxborough mesh control network is specifically only for these number of devices, these types of devices, we will allow you to connect whatever device you want to your control network. And this is why we're starting to call this an automation network. We're able to connect Triconic safety systems directly to the automation network, drives, right? New I/O families that we have, so Modicon Edge I/O NTS, Foxborough Edge I/O NTH, I/O from partners, right? So this is Stahl I/O, right? we also are able to connect RDUs from our remote operations portfolio, and you'll see that we have these cogs at various places in this architecture. That's really where we are able to run control, right? And we're showing that we can also run control in servers, right? So what this means is that the control runs at this server, it connects to the network, and then your I/O via this communication node also connects to this network. And that is a different architecture that will allow you to essentially start using Ethernet, right? Connections to wherever your I/O is distributed, and it allows you to reimagine the system as we move forward, right? And obviously, we'll have cybersecurity, right? And if required, you'll be able to connect and send data to the cloud, right? We'll have a mechanism to operate and maintain the plant as well as engineer the plant, and we will be using Aviva historian and connect, record data locally, as well as send it to Aviva Pi, for example, if that's your enterprise historian, right? So these elements, right, this system, right, exists today, with the exception of this 200 series integration, right? You can architect and use this system today. So when we look at some features very quickly, and I don't intend to go through every single bullet point because we have a large number of them, we have new control and I/O families. We have engineering efficiency in forms of process libraries. We have AI co-pilots for procedural and batch automation. We've also bought machine learning and large language models, right, to help with control and application generation, right? We're able to create displays from PIDs, right? From an operational perspective, right, we support procedural and automation, so ISA 106, right? From a system management perspective, right, we're able to deploy both control and compute applications. And we released a new feature, a patented feature, which we call high availability disruption avoidance. And what this allows you to do is that it allows you to have a controller somewhere on your network, and should you change one of your controllers from redundant to simplex, either or maintenance or upgrade or even a failure, that other controller can automatically take over, right, and maintain your system availability and reduce the mean time to repair. So HADA is an important new feature, and obviously openness, right, our commitment to adopting open standards, right, being part of the Universal Automation Consortium, being part of OPAth, being a part of the board. The cloud connectivity, a number of different mechanisms to send data to the cloud, whether that cloud is local to your site or remote, right? Controlled at the edge, right? So we're supporting the IEC 61499 control engine. We are also supporting the 1131 control engine, right? And we allow the deployment to multiple platforms, right? Abstracting the control from the hardware, right? And compute at the edge. So you can write your own applications, right? You can deploy your own apps, and by being part of the Margo Alliance, we will be allowing apps from competitors, right, as well as partners to be downloaded into our controlled compute platforms. And then interoperability, even more ways to integrate, right? So lots more protocols, right, that we can integrate. From a cybersecurity perspective, which is always in mind, right, ISA Secure 62443 compliant, both at the component level and the system level, adding role-based access control, allowing standard IT tools, right, whichever ones you use, right, to be used on the system. So really changing the way you operate, the way you architect, right, your systems. So when we look at Foxborough SDA, right, and this was launched back in 2021, right, we have solutions across all segments, and this was the count as of right. So Foxborough SDA is available today, right? You can see the various components that we have, and we can start deploying it to your sites. So we've had this very deliberate strategy of developing a system in parallel, right? And we have this deliberate strategy so that we can prove it is it exists, it's proven in use, and we then will converge with that system. So for the install base, we have the Foxborough DCS convergence program, right? And the aim of that convergence program, right, is to allow the Foxborough install base, right, to converge with Foxborough SDA, right, at your pace, right? So we will introduce, right, to you field proven features that are part of Foxborough SDA, and you can adopt them as you require. Now, we've identified 3 steps for the convergence program, right? The first step being modernizing the Foxborough DCS platforms, communication, cybersecurity, and system management. After that point, step 2, which is starting to adopt the features and the architecture that I've shown in the previous slides, right? And then step 3 is to provide that single operational HMI control runtime. So just to reiterate, okay, we're not changing anything in terms of Foxborough DCS lifecycle. Our commitment is unchanged, right? We're going to provide common software, common networking, common servers, common workstations, common control and compute platforms that will be used across both systems, right? And we're committing to simplifying system upgrades and maintenance. So the next slides, they go through how we do that in these 3 steps that I've outlined. So if we just look at this slide and a simplification of sort of the functional areas we have in a DCS, right? So we have cybersecurity, we have some form of operational HMI, whether it's control HMI or box view. We have ways of managing the system. So to the system manager, right, we have some form of engineering the system, whether it's ICC or control editors, and we have some form. And then we have a control network to which controllers connect, and then the controllers connect to IO, and the IO connects to the field devices. As we modernize the Foxborough DCS, we will introduce a new control platform that replaces the CP280, right? The CP280 released in 2014 has no changes planned in its life cycle, right? We will introduce a new platform, right, that allows you to connect to IO, so there's no change to your IO family. But that platform will use a different type of technology. So we will be containerizing the control run. The reason for doing that is to really get to that sort of plug and play simplification of system setup. And so there'll be a platform, right? And as I said, there'll be a way of directly connecting IO as you do today, or you'll be able to use the edge communication node and connect to your IO, which then connects to a network, and you can decide, depending on latency, there is an aspect where you run your control, right? We will modernize to use the Aviva Historian. In the first step, we will continue to use ICC or control editors as you have today. We will modernize the system management, right? So that you'll have one experience that allows you to maintain your existing Oxford DCS assets, but also, right, allow you to add and modernize, allow you to add and manage the new elements that Foxborough SDA makes available to you. And in the first step, there's no changes to your control HMI or Foxview, right? And cybersecurity, right? So if we look at that in more detail, right, we want to emphasize, right, we're preserving customer investment, no changes to IO, no changes to intellectual property in terms of HMI, control databases, right, or historical data, right. The platform changes allow you to extend your life cycle, right. We bring modern IT OT technology, and we really make this infrastructure ready for AI deployment if that is the journey that you're going to take, right? And all of this starts to build a foundation for autonomous operation. Again, the journey that you may decide to take, right? So, plug and produce, right? Our goal is to improve the system definition process, right? You will plug in one of these controllers, which can be the controller compute. The system will firstly identify that it is a genuine Schneider device, will have certificates, etc. Right? There will be a device agent embedded in the control platform. That device execute management application, and it will onboard that device, setting up station and other security aspects. Control database application can be deployed, right? And the reason that we're making these technology changes is really to simplify, the setup, maintenance of the system, right? Through this technology. Benefits: increased cybersecurity, so device genuineness and tamper detection, right? System level SL2 and controller level SL2 certification, right? We'll be introducing real-time communication using OPC UA. So we understand that a client cannot just upgrade everything in one go. So we will be supporting communication to existing controllers using our current communication protocols, but also to Foxborough SDA using the web, right? So we'll have the ability to share information from the controller, right, to both existing systems and new systems, and as you upgrade your systems, that communication to the existing systems can essentially be turned on. We're enhancing system management, so a single window for both Foxborough SDA as well as your modernized Foxborough DCS, as well as your control and compute applications, right? And at this point, when the system architecture has been modernized, you can effectively start adding the capabilities that I talked about earlier. So you'll have your modernized control platform, right? It could be an upgraded CP280, or you could be running your controlling servers, as I said, depending upon latency determinism, privacy type requirements, right? Or you could have one-for-one upgrades, but then you could start adding Triconics directly onto the control network and communicating using OPC UA. You can start using our high availability automation processor AP310, either for control or for compute, right? You can start adding UIO boundaries available from Striker Electric or even IO partners, right? So it allows you to expand your system with Foxborough SDA components, as well as maintaining and modernizing your existing system. So when we look at what you'll be able to do right? And in just in a little bit more detail, right? You'll have the ability, as I said, to add different I/O families, not only from Schneider Electric, but also from partners, and you'll have the ability to integrate seamlessly other types of sensory technology. So whether it's Bluetooth, whether it's Wi-Fi 6, or whether it's 5G, right? You'll be able to integrate those, right, as either primary or ancillary information to help with the control of your fund, right? And the key thing is that we'll be able to share data between controllers, right, using OPCUA as we move forward. At this point, right, if you are a controlled HMI user, those controlled HMI displays will import into OMI, right, Aviva OMI, which is the enterprise HMI used by Foxborough SDA. So you'll be able to actually have a single HMI, right, for both for existing applications and also the new applications with Foxborough SDA. At this point, there's no change to your control engine or your control database, right? So there'll be a common historian, common system management, common runtime, right? Will come in the third and final phase, right? So when we look at that third and final phase, this is where if you have box view, right, we will have to migrate to OMI, right? And where you have either controlled editors or ICC, we will be using the Foxborough SDA build time with a new control engine, right? In terms of your control applications, there will be exact equivalent. So if you have a PID block, at the moment, the PIDA block, there will be a new PIDA block with the same functionality that we currently have. So the approach to the control runtime convergence is, as I just described, right, equivalence of control blocks, whether they're the regulatory control like PID and lock input, or whether it's sequential control, or whether it's control running like ladder logic in FBM. So providing the equivalent control functionality. So today you can start adding, right, Foxborough software-defined automation to your existing system through OPCUA essentially. So with your existing system, without any modernization, right, you can start adding those components, some of which you can see on the demo stand outside conference room, right. In terms of the convergence program platform, you'll see that we are in the process of developing that platform. So we've taken a platforming approach, and you'll see that the first version of this platform you'll see in the demo stand, which is the edge communication node for Edge IO, right? In terms of its physical properties, in terms of size, the cables, it's all backward compatible to what we have for the CP20 and essentially the CP20, CP270. There is a small 30mm or 1-inch difference in height, but essentially you'll be able to reuse all of the existing cables, etc. There is as I said, new functional aspects to this that will be containerized. You'll be able to use your existing cables, but you also have the ability to connect more to this, because this is not just a controller. This is essentially a switch with a control and compute platform. So all of those network ports you see here, whether they're on the base plate or the SFPs, right, you'll be able to decide which way you connect to your existing control network, right? And then you obviously have your I/O cables or the connection to the 200 series, right? So this is the basis of the platform, right? The first version is already in development and will be released at the end of this year, right? And then subsequent platforms will be released essentially with different firmware. So just to look at the demo stand that you have out there, right? Where we have the panel in two parts, right? The left-hand part is changes and uses in Foxborough DCS. The right panel is everything that's available today in Foxborough SDA, and this is the control platform that I just talked about, right? Here you will see that it has different connectors for Foxborough Edge IO that was released at the beginning of the year. But we will have another version of this base plate that allows for 200 series. Now this IPC up here is our way of demonstrating to you the containerization of the control processor 280. So inside this IPC, to prove that we are being hardware independent, we containerize the CPU280 runtime, right, and are able to run it in an IPC, right? And then obviously, if you want to do that, when you modernize, you'll be able to do that. If you want to carry on something that looks like CPU280 does at the moment, you'll be able to run it in this application. And again, we'll be able to connect the 200 series IO or Edge IO or any of the other IO families that offer such architecture supports. So our commitment to this modernization of our large install base, right, is very real. We wanted to show you the progress that we're making, right, and the path that we're taking, right. By releasing Foxborough SDA, so that you can see what's being developed, what's being proven, right, and then modernizing your existing system, right, at your pace. To take advantage of these features. And that's the last slide that I have. Apologies for going at speed. It normally take about 90 minutes to discuss this, but given the time, I'd like to speed up. So questions, myself, and the floor.
Thank you very much.
Good session. So according to the plan, we still have 20 minutes for questions. That's quite a lot. We don't need it all, but if you have any questions, please speak up. I will repeat them so that Baljeet can understand them because he doesn't hear our room audio, and then he's ready to respond. Any surprises to anyone? So the room is radio silent, Baljeet. There's a question. Ted, please. So Ted is asking if we have a general timeline on the 3 phases that you mentioned for the convergence program.
Yes. So when we look at the release of the control platform, right? We're looking at 2028 to 2029, right? So the first phase will be available in that time frame.
So we make consciously no commitments as of today, right? We share a plan and a strategy with everyone to eventually also prepare strategic thinking, but clearly this is a wider outlook. It's not something that has a price tag on it and that has a release date on it as of today. Yep.
That's correct. That's correct.
First, did a soft launch of what we're doing. Right? And actually, last week we released it officially ARC world. And I mean, really, this is in response from your request last year. What are we doing? Really would like to hear your feedback. That we would take from you. Funding, yeah, all of it. Will be interesting to hear if that perception that you had last year, if it actually really changing.
We're glad you're finally giving us a roadmap. Dragons. That is that a lot of wish the time frame was of us got older, updated, and it's be a long time frame. But hey, I want to get this.
So just to add some more detail, so when we see you next year, right, we'll have this controller running in this platform, and we want to show you this progress to that end, right? So that it's not just a PowerPoint or anything, right? So our ambition is to incrementally show the progress we're making. So you can see, for example, the progress we're making around deploying containers, managing foreign compute apps with Opera SDA. And then we make that available for the Opera install maintenance, right, at your own pace. But in terms of hardware and other platforms, we'll be giving you peaks, call it what you want, prices that you can see for yourselves and make your plans accordingly.
Yeah.
The software defined automation, it is a big.
Yes.
Want to comment about that? Because they want to take advantage of that new technology. I mean, we can have conversations of the architect. Do you want to comment?
Yes, absolutely. Let me just go back to this slide. So with this slide specifically, we can add all of this capability to an existing, right? And we would interface the two systems together using OPC2A, right? So if you want to add Polygon HIO ATS or any of these other capabilities, we can do that today because it's available today, and we did the formal launches, pushing to the ARC last week. But this has existed, right? This technology, this capability has existed, right? Since 2021, right? And we have references across multiple segments, multiple industries, and we're happy to engage with you, right, to look into specific use cases and how we can allow you to get familiar with this technology, maybe in a in one of your labs or in an online situation, right, so that you can understand more about this and before you introduce it live, although it's available for you to use right now.
I just had a question.
Sure. You were showing in your displays there using Modicon IO as an example of some of the other IO platforms you can integrate. And I was just curious, how native does the Modicon IO appear versus traditional Foxborough IO?
So the question is, we show on our slides that we have other Foxborough IO, like Modicon IO. The question is, how native is the integration of that IO into the future?
So if I go back to this slide, right, and I just look at here we have IO from our Stahl, right? And Stahl has a OPC-UA server and client embedded in their I/O head, right? And then that provides that real-time information and system management information into the Foxborough SEA solution. Similarly, right, Foxborough SEA supports Profinet, supports Ethernet IP, right, supports Modbus TCP. So we have multiple ways of bringing that third-party I/O or partner I/O into the system. Similarly, we can do that even with the Foxborough FTP2A we have. We support Profinet, we support Ethernet IP, we support OPC-UA, and we can connect to different I/O bands. So that is our mechanism for integrating under I/O.
So just to clarify, no particular advantages of Modicon IO versus other partner IO or vendor IO.
So this is budget. If there is no particular advantage of any IO, the Foxborough IO, when we claim that the communication is just existing and supported.
So I think of course Schneider Electric wants you to buy Schneider Electric IO, right? That's absolutely what we would prefer to have. But there are other instances where, say in the skip, for example, you have a particular IO because the process license your skip provider only will support that IO. So what we're trying to do is allow you to get that IO into the system. Now, one of the key things about the IO integration is not just the real-time data, right? So the control information in personnel, but also the system management, the upgrading, and obviously we with say the NGIO NPS, which I have here on the slide, or NGIO NPH, we have that additional integration into this, right? So, for example, you can automatically deploy this communication node, right? Whereas there will probably be a few steps with a partner IO subsystem, and that's really because we don't have all of the standards developed and released to allow the system management aspects, right? How you further upgrade the central deployment. But those over time will definitely come, right? So just like we have had standards for Modbus, Ethernet IP, Profibus, OPC-UA, for real-time data, how we actually manage the system, right? How we add the IO, how we firmware update the IO, what health status we get from the IO, right? That's all in discussion as part of US automation, OPAP, and more, so that we truly can get the same experience across different IO bandits. We're not quite there yet from a standards perspective, but definitely there are standards bodies out there, especially around FPC, FX, TSN is time-sensitive networking, where all of these aspects, not just IO but communication and system management, are all being discussed by various members of the market and standards being developed. But right now, obviously, better experience with our IO than a partner IO at the system management level. But that will change over time. We will equalize as the standards get developed. I hope that answers the question.
Yeah, thank you very much.
Any other feedback?
First part, is there a software OS
requirement.
So the question is that we mentioned hardware independence in the first part of your slide deck. I guess this mostly aims at the server workstation level and home level. So the question is, would we specify some OS minimum requirements or some performance requirements to qualify a third-party platform? Is that the right question? Yeah, so are we looking at the specific Linux distribution? Are we looking at something specific that qualifies an external product as being capable of running our Foxborough SDA platform?
Yes, so if I just take by chance on the industrial networks with Foxborough SDA. So right now we use Extreme switches, right, for the Foxborough control network. But what we've done is we've worked with Moxa, Belgium, and Extreme and said, these are the requirements for our automation network, right? Do you have hardware, firmware, software that meets those requirements? And they then do the testing, and we add them to our portfolio. So from a network perspective, Foxborough SDA, you have 3 choices of network and supply, and that will grow over time. So we are essentially defining, as Marcel says, the minimum requirements, right? And then you can make that choice, right? And again, those choices will consider, your overall cybersecurity posture, how you want to maintain the system, right? How you wish to expand the system and upgrade the system over time. But what we're saying, if I just look at this in a very simple way, right? Sorry for flipping back and forth. We're giving you more choice. So when we move to the automation network, right, we're allowing you to essentially connect whatever you deem is necessary for control, right? And with the additional time-sensitive networking, which allows you to allocate bandwidth, right? Allow certain traffic to have a higher priority over other traffic. You'll even be able to connect your processing CTV or other systems to the automation network and really simplify your network design, lower your cost, whilst increasing your determinism and security. So it's all through that prescription and adoption of standards, right? That we aim to provide you with that flexibility and get away from hardware obsolescence and even better locking, right? Of course, we would like you to buy all of our equipment, but you will have the option moving forward to make your own choices. Yeah, even the server. Yeah, even the server. So one of the key things about servers that we've obviously been very prescriptive about whether it's HP or HP servers or Dell workstations, and that really has been around how control network functions servers as we move towards standard ways of network card bonding and redundancy. You'll be able to choose which servers you use. And for example, we will allow you, right, because it'll be your decision, do you want to use VMware or Hyper-V, right? So we'll allow our software, which will be containers, right, to run on these applications with decoupling our software from the hardware. Right? So by virtualizing, by containerizing, right, you can choose where you want to run that workload. But similarly with cybersecurity, right now we say use Tredex, right? We say use network management software from Extreme. going forward, well, we have already have 3 sets of network switches, right? And as we move forward with virtualization and containerization, your servers, or even you can have a local cloud that does all of your operational maintenance, data storage type functions.
That was received well, thank you. I want to add one sentence on a very high level.
We still consider us to be a systems vendor, right? So we're not selling people hardware pieces, software pieces, throwing it over the fence and let you figure it out, right? We want to deliver this holistic experience of delivering a system as a solution and supporting it also. But we, as Budget explained, we develop our product further to become more agnostic, so to allow choices for those that ask for that. But if you want to have the holistic experience of a system, then we recommend proven choices that we sell. Another question is, please.
Does this mean the mesh is going away? The Foxborough mesh that we use now?
Did you get it? Budget? So the question is, does this mean that the Foxborough mesh network, the control network, goes away as it is?
The Foxborough control network doesn't go away. We will still need a network to obviously connect the various functions in the control system. It will just become more agnostic. If I just go back to what we're doing with Foxborough SDA, right? These are the industrial network partners that we've selected, right? And you'll have the same choices, right? Or upgrading your mesh network in the years to come, right? And for example, if you want to use Cisco switches, which doesn't not appear here, and Cisco switches, convergence times, etc., under failure, yeah, go ahead, we'll publish those, and you can use whatever switches you wish. But the function of the control network will not obviously go away. We're calling it now the automation network because we will allow anything that you deem to be automation related to connect to it.
With that being said, your mesh network is just a fiber network, basically. But how is your system definition monitoring these third-party devices?
So the question is,
Putting up all these definitions, how does system management and system monitor cope with all the changes?
Right, so that's an excellent question, and one of the things we do in the first step is look at a modernized system management. So right now, okay, we have functions within Foxborough PCS, things like device monitor, right? That monitor specific proprietary messages from the controllers, I/O modules, and workstations. As we move, right, open software defined automation, right, that device monitor message, right, and function is changed from being Foxborough specific to being industry specific. So, for example, if you are an OPAP user, right, or you adhere to OPAP, Redfish is the system management communication protocol being promoted for system management device diagnostics, etc. So we're moving using standard or more broadly available ways of reporting health. Right. So right now we do not support, for example, third-party devices in System Manager. Right. They're not monitored by System Monitor, but the new mechanisms for system management allow that. Right. So and this is where I pick up on what Marcel said, right? we want to provide that method of our software that says, right, the Schneider Electric system management software, right, not only allows you to deploy your applications, whether they're controlled, but it allows you, right, to integrate your Boxer switches or your Belden switches or your Herschel switches, right, and the diagnostics from them, or from your Dell blade servers or your HP blade servers or your Lenovo blade servers. So we're replacing our very specific ways of getting data, standard ways of getting health and diagnostics.
Makes sense.
It does, but it leaves a lot of other questions. You're opening it up to different switches and interfaces. Like, you know, if I've got a burner controller running Honeywell Slate, why can't I add it to definition? Do away with the FDSI block. Tell that it's Modbus we're talking to. Able to put that in there, but we can monitor that burner control through the system manual. So if it failed, you get alarm, just like we do on device today. That's what we sort of been asking for. Things that will be able to plug these modules in definition. System monitors work. Be a third-party device on the system.
On a very high level,
The current concept of how the system works is based on the idea that we define everything in SysDev, we deploy it to the system using the committed install process, and this is what Sysmon and system management actually monitors. But as we all know, the system has evolved ever since, and it already has evolved today, right? As an example, if you have a virtualization host, you don't have to configure this in SysDev, so Sysmon doesn't know it, right? And people complain, oh, we're getting a Foxborough DCS, we monitor the VMs, but we don't monitor the hypervisor host. This is a problem. So the long story short, on a very high level, we will introduce a new industry standard system health and status management environment that overcomes this limitation by completely getting rid of all these legacy processes and concepts, which essentially means we will change the whole thing, right? So it's not like we bolt something on or we add new devices or every new switch has to be added to the choices. We will get rid of this altogether and you will get a brand new software that follows the new concept, is more open and more future-proof and CRA compliant and different.
Foxconn communication, you guys have used the Honeywell DP or Yokogawa or whatever. You know, like they open up to have FDT part devices open for it. So I think very similar.
And reinvent any wheel here, right? So we did a careful analysis on the industry landscape. What is out there? What is what people are using? What is what user groups promote? And we looked very deeply into different options, and we chose the one where we believe they are most future-proof, they are inherently cyber-secure, and they deliver to our ambitions, which is to become a truly software-defined open environment.
These are very safe, universal. You know, like these are going to take
But we also want to be clear, right? We try to position ourselves as a vendor a little bit different than just commoditizing everything. If you look at Open Process Automation Forum, the paradigm is that everything is a commodity, everything can work with anything, and orchestration, it will happen by something, but it's not really well defined, right? And within each of the elements of an OPAF compliant system, the vendors can do whatever they want as long as the communications interface is compliant to the standard. We go a step further. We say we want to be software-defined and open, so we follow those principles to stop being exclusive because of proprietary standards. But we want to deliver that additional holistic experience in having a consistent system health and status management environment, having a consistent, for example, user and security environment, and still being perceived from the user experience point of view as a systems vendor that delivers all this orchestration and this centralized management while we overcome the disadvantages of being closed because of proprietary decisions of technologies. And this is the concept where we position us a little bit different. why we choose, for example, OPC UA as the communication standard, same as OPAF, right? And there's other elements that are also same, like Redfish as one of the choices for system health and status management reporting, which is also a choice driven by OPAF. So we go this way, but we want to overcome the conceptual limitations of existing architectures with what we do. And it is a lot more disruptive than what you've been seeing in the past. So if you look at the last 20 years of evolution in our system, we have been changing stuff all the time, right? We changed operating systems, we changed processor types, we changed architectures, but we never changed the underlying paradigms of operation, which is the time slice model of runtime execution, which is the real-time communication space, the OM space, the CSA as the master of all names. With the new system, with software-defined automation, we will also modernize those paradigms, which means it's not just something you just add on and it will magically work, right? So we have to look at it a bit deeper. We have to introduce encryption. We have to introduce authentication. We change some protocol standards. We change the system management environment. So this is a little bit more disruptive than we did in the past. It's not just the next DCS, and it will not just magically work, but it will future-proof the technology, and it will help us sustaining our investments into the wider future, which is why we position it as a 15-year outlook. Dave, you're trying to push on, stop these guys so that we continue on the roadmap. One more comment, yes.
Education, a lot more IT. As these proven over IT guys are getting time to monitoring like Redfish. Monitoring. Now that these rightfully so, the OT space is slow to adopt this. Right? We don't want to go grab the latest thing. It doesn't work here. Now people start to go, okay, how long was it that was everything but your eyes? That for you. Finally, it's like, trust it now, we'll let IO go on you. That will never start. Now we're seeing IT. Can we trust you? Right, we can push them down.
And to answer your point,
we're adding elements that are demanded by OT, but not so much required by IT applications. I'll give you examples. When you look at OPC UA, we add time-sensitive networks, which is a quality of service layer on top of OPC UA that helps with determinism and bandwidth managing, quality of service managing of such connections. That is an OT requirement, but we apply on OPC UA as such because it is the proven, I would say, global future industrial common language of communication. Same thing is with Redfish or with other elements where we adopt proven technology, but we add elements that help with the OT use case. And I don't really see an opposition between IT and OT. It's a converging technology. And in companies that manage this well, those people actually work together and not against each other.
That point, on the field proven aspect, in the AP310, right, we have a Redfish server, and in our system management, we have a Redfish client, so that we've already adopted that technology, and we will learn over time how we need to enhance it, right? But we've already taken that path to be more open. So, Redfish being adopted, it will mean that if there's another device, whether it's from Schneider Electric or something else, right, we have that capability to connect to that Redfish device, set it up, receive its messages, right, and integrate them and provide them in our new system management. So we're already on that journey. That's what we wanted to discuss with you, in greater detail aspects. Between install base and phosphor SD, but also IPO convergence.
very quick. This is an industry trend, right? I mean, if you're following competitors, if you're following other automation competitors, I mean the industry is taking us there, right? The adoption of this is actually going very fast. I read the other day, the internet, it took it around 10 years for people to adopt it, to go everywhere, right? Cell phones, it took around 5 years. Artificial intelligence, I mean, we are already using it, like the adoption is so quick. And again, this is an industry trend. And I hear in the market, oh, Foxborough is long in the tooth, it's like we are defining the future of industrial automation, right? I mean, we are leading the pack here, and we're very proud of it, and we're very proud to share with you all, what we're doing, and I hope that you guys can see that we're investing, that the Foxborough DCS, there is an evolution of it, right? But we're heading in the right direction, right? So your investments are safe. That's what really the message here is.
And to be also clear, this is not cast in stone, right? All this is wet paint as we speak. We share really a wider view in the future. So things might change in parity, in technology, in sequence, schedule. So this is really like trying to open this conversation, which we will continue the next years going forward, where we refine the strategy and start delivering products. There was a question over there.
Asset technology. Back in answer that
Is a system asset ontology something that helps answering the question with system management? So I would position it as such. A system asset ontology or hierarchical ontology is a structure of a namespace. And it could be of any type. It could be a topological structure. It could be a commercial structure that comes out of your SAP systems for example. Or it could be anything else that you might sense being useful. Some industries have special naming systems that have a hierarchy. Like in power plants, there's a certain naming system that follows certain standards, so we could deploy that into a system. Now, what does that mean? If we have a hierarchical asset ontology inside our system as the base of the namespace, we can leverage advantages like having applications being context aware. So if an operator, for example, looks at a certain reactor, we know that this operator is solving a problem on a higher level in the process. While if this operator drills down into a valve or a pump or a certain measurement of that reactor, then we know by this fact only that the operator is having a different context. The operator is now trying to eventually troubleshoot a problem with that very device. So with that context knowledge, we can give the operator different sets of information, eventually more detail. Think of it like Google Maps. If you look for a location in Google Maps, you give it an address and it zooms in, right? But then when you come closer, you eventually want to know which is the actual number of the building. And you zoom in, and while you zoom in, you see additional detail being displayed on the map the more you zoom in, based on the intelligence of the app knowing, oh, the context is now this guy wants to know the numbers of the buildings and is not anymore interested in the numbers of the interstate highways, for example. So you could call it this way, but the core element is not the unification. The core element is the hierarchical nature, so that the context capability is actually enabled. With our current namespace, which is compound block parameter, we don't have any hierarchy. We have like compounds that contain blocks. And that is way too narrow to actually deliver to this promise of being truly context aware.
We got a question from chat asking about the FCP 270 in regards to when will it be moved to the obsolete phase, or is that still undetermined?
Which was the
FCP 270, right?
The FCP
that hasn't been determined yet. Yeah, that's actually nothing to do with the conversation right now. But yeah, we 270 today's in lifetime, which means it's our best effort. We've been giving some great effort to 270. I know that we've supported the 270 for quite some time, but my advice is if you're at the 270, see your local CSC and get to a 280. but there's no date for obsolete yet for
Right.
270.
Any more questions to Baljit on the Foxborough SDA future DCS topic? If not, I would suggest we close this session and we start diving into the FDSI FTC20 topic to actually bring us until lunch, which is planned for 11:30. So we have 30 minutes for that. And I would like to thank you, Baljit, for your presentation and for explanations, your responses to questions, and have a great day.
Okay. Last session for lunch. Probably a very important session, and this is around the FDSI, the Field Device System Integrator, the FBM 232 and 233. There's quite a bit of interest right now in the FDSI. We're going to talk also about the FDC 280. But when you look at the life cycles, you can see that in February 05, we introduced 2005, 20 years ago, we introduced this FDSI, and we've been kind of plugging along. And then as of today, this day, all four FDSIs, the FBM 230, 231, 232, 233, are all mature. You cannot get them. Now, I know that a lot of folks have had some on order for quite some time, right? And you're wondering where they are, and if you Roger, you had some on order too for quite a while, right? And if you notice in Bioautomation, it had a 52-week lead time if you wanted to get some more, and now they're not there. So the good news is we have started shipping the FDSIs. I know at a minimum, for a fact, 163. There's a that we've gone up to 300. I think our backlog was around 900 to 1,000 FDSIs. So that's good news, right? We're actually shipping them now. So right now we are in the support phase, the mature phase. There is a good chance that the date that transitions from yellow to red, meaning the transition from mature to lifetime, there is a chance that we can move that out to ensure that support any longer. Now I'll pause there for any questions. PSI. less I owe a huge favor. Because we're going to make sure we have that support stock, because we got to basically support those 30, 40,000 of them in the world. So I don't know about indefinitely, but I mean, we certainly have to support for quite some time. During this support period, we are building a new FDSI. We're not calling it FDSI, we're calling it the Ethernet FBM. We have a target release date of Q1 2028. Now you'll see some important things there. Form factor replacement for the existing FDSI, meaning 200 series base plate, take one out, put one in, or you get a blank spot in your base plate, put one in, type of thing, so you don't have to run fiber. You don't have to have a new base plate. So and it's going to be basically under the CP. Okay. So this is official. We are doing this. We're not thinking about it. We're not doing a voice of customer. We've done plenty of customers. We heard a lot. This is official. We are doing this, and we are targeting for 24 months from now to have it. Okay. It will support the first release. We're looking at the Modbus TCP client, the Modbus TCP server as well. Again, we can use that. We're gonna be able to reuse our Ethernet cable. We talked about how much we love Ethernet, right? And it's just basically we haven't really decided what we're gonna call it yet. We're thinking like the FBM 232B. You like it? Yeah. Right? Thinking out of the box a little bit there, right? So this is official. We're doing this. You can't get the ones, you can't get the 232 and 233 right now. So what we're doing in the meantime is we're going to fulfill, Ishmael, we're going to fulfill that backlog fast as we can. I know you're waiting on some. I know, was looking at it right before I got up here. Anyone else waiting on FDSIs? Roger, are you waiting on any? Yeah? Not too bad. Are you in a bad spot? You're okay to wait a little bit longer? All right, good. Okay. Okay. You had 6 on order, right? You have you had 5 on one and one on another. Maybe a spare. All right. So we still, you know how I said, we're investing. Foxborough is investing. We're investing in the Foxborough DCS. We have a path forward. The talk around SDA shows the path forward. We're investing quite heavily in the FDC 280. The FDC 280 at one point. First release Modbus. Yeah. You're going to ask the first release Modbus. Yes. Yes. First release Mod. You're good. Yeah. Make sure you ask Marcel for Ethernet IP, right? Yeah. $8 months. Understood. That's why while we work through this, right, and we will work through this, we say first release, which implies there's a second release, which implies there's a release, which implies we will do Ethernet IP eventually. Start at the top and work our way down. What's our number one driver? What's number two? Ethernet IP is probably 2 or 3. Control logics. So yes. Port. Yeah. Yeah, the right. So you're looking at 2 years. So you're looking at 2 years, right? So in those 2 years, where do you think all the development's time? It's not for importing drivers. It's developing the hardware and going through industrialization and I think there might be there's probably going to be new firmware on the module. So it's not going to be another, Dave. It's not going to be another 2 years after that. All right? You can quote me on that. FDC 280 capabilities. We're doing a lot with the 280, and the FDC 280. I think I saw 2 sessions in the agenda. One about implicit driver for Ethernet IP, and another one about concurrent protocols. Those are both important things that we're gonna talk about. I'm really happy that we've got sessions on them. You look that we do have TSAA for the Triconics integration, Modbus RTU and Modbus TCP, OPC UA client, Ethernet IP, and now we got Profinet. And one of the projects that we're taking on starting this year, completing next year, is basically online upgrade. I didn't say enhanced online upgrade, but we're doing an online upgrade, the FDC 280. If I said enhanced, it would imply that we had an online upgrade already. So we're doing an online upgrade project for the FDC 280 because it is a controller. I mean, it runs the same blocks as an FCP. It is a very powerful device. You can do concurrent protocols as well as many devices. 8,000 blocks in it. So we actually have some clients that are looking to be able to upgrade that FDC 280 online without taking off. So that's one of the areas of investment that we're doing. Modbus we've had around forever. To your point, Joe, that we've had Modbus forever. That's going to be there. That's part of the concurrent protocols as well. TSAA for not only for Tricon but also for TriGP and also for Tricon CX. OPC UA client, we've got a couple of different more of the later releases we've done in phases. We've done basically phase 1 to meet some customer requirements. Phase 2 we released with concurrent protocols, meaning a single OPC 280 can run OPC UA, can run at the and now we're doing we're doing an OPC UA client that's out this year to do multiple or redundant servers from the OPC UA client. And then Ethernet IP, I know we're doing a third release this year. We've already done a release in 2024 for the standard driver, doing control logics PLCs, and then on the custom driver, doing implicit mode. Is that the driver you're going through? Is the custom driver, Dave, or is that? It is, okay. Yeah, so you'll know. So phase 2 was the implicit mode with concurrent driver support. If I go to the next slide, 26, we're looking at support for fault tolerant, support for DH plus bridge, interfacing to multiple Allen Bradley PLCs, support of the device net bridge, for multiple DeviceNet devices. That's a use case. Concurrent drivers as well with this one. This one's probably late this year. Application to configure the EDS files. Also qualifying the Ethernet IP scanner driver. So these are all driven by customer, very specific customer requirements. So basically what we're doing is we're taking that custom, making it a standard. As soon as you make it a standard, you get the concurrency for other drivers. Okay. And then Profinet, we released in last year in May. It was one of our very more complex drivers that we did was Profinet. We're actually adding to that here as well. We're doing support of APL switches for interfacing to Profibus and Profinet devices. We're supporting a migration path from Profibus to Profinet, and we're also getting some of the certification, Profinet certification board to. It was something that we didn't do last year, and we kind of let it drag a little bit, but we're doing that this year. So basically, areas of investment for this year include Ethernet IP. It also includes adding more to the Profinet stack, and then enhanced online upgrade for FDC 280. In addition, we're doing a Ethernet FBM or an FBM 232B and FBM 233B. We're targeting the first quarter of 2028 for that release, to start with Modbus for the first release. And also, as a summary, we are shipping FDSIs out of the factory. Finally, at a minimum, we've done 163 of them that I know of. I think we may be up to 300. So those, how about any day now? Any day now. Soon. Okay. So the reason we pulled that out of the roadmap, we thought there was going to be a lot of discussion on FDSI or FDC 280. We also wanted a smooth transition from what I call the Foxborough roadmap to the Foxborough SDA roadmap. So it kind of flowed, and then, but I think we're going to do Q&A this afternoon at 3. Is that what we're going to do? Okay. Is it one question per person, or? Can't choose, yeah. Just can't. Yeah, about the questions, we take the questions very, very seriously. We'll slough them off very seriously. The one in the chat about the 270. That's a good question about the 270. So yeah. Any more questions in the chat right now, or nothing right now? So the question was, since we're in mature, and since we're not getting a equivalent form factor replacement until 2028, what can we do for 2 years? Well, this is where the FDC 280 comes. You have to consider FDC 280. if you get in real trouble and you really need an FDSI, are we recording? We're gonna have some in MEP, right? We gotta have some in our module exchange. Yeah, we acknowledge, we recognize FDC 280 isn't a one-for-one replacement, and especially when you're talking about remote I/O, running fiber, redoing the database, getting the cabinet space. Yeah, but in the next 2 years, you should consider it if you really need something in the next 2 years. Okay, good question. You don't get to write one down later. All right, Dave, I got 1119. Did I say that? Yeah. This year. Yeah, this year. I mean, we got, like I said, we got this going on. We got Profinet going on. We got an online upgrade going on. So we're trying to just balance it based on customer commitments. Q3-ish. Oh, we're doing this for you. Yeah. Ryan? Minutes and questions, yeah, and then do lunch. And all right, good. It's good. Good.
Sorry.
noon sessions. So we could round up the people from outside. I'm looking out there. We don't have enough people. I'll go get them. I'll bring them in for you in a second. So go slow at the beginning. This next group wins the award for coming from the furthest away, all the way from Belgium. We have Lieven Tauman and the Talsoft crew. This is Ilse Tauman also. He travels with an entourage. So here he is, and we'll let him get started, and I'm going to go tell everybody to get in here.
Great. Thank you, David. It's great to be here. We were here last year, and just saying we are back here means that it was good, and I like it to be here. Okay, so I'm leaving. Who are we? Talsoft, I think, is not that known by the whole world, but in fact, with Foxborough Systems, we are already more than 30 years of experience with it. So it started in the Unix world, and then all the versions and systems go further. What we do is, in fact, we create software, but the software itself is all produced in-house, and for us that is very important. And the reason is that at that time we have a good relationship between customer and Talsoft to know what really is required in the software and how it should function. Okay. All said, we are a family company, but I should say talk to one of my kids who are also in the room to know what it means working together as one whole family. Okay. Well, I would like to start with general scope, that is that how to reduce your engineering cost. That's the main step. And there are a couple of main key components to create that. That's what we believe. And one of the major part is that you should create a system based on templating and structurize it. I give you a very easy example. If you have, let's say, about 10,000 tags, then you need to work on it. But if you can reduce that to about 200 templates, then your engineers take care of it. So the amount of work is really reducing dramatically. And that's why also in the newer Foxborough idea, there are to use that structure, I should say, invest in it. Another part that is for us important is that if you see your whole company production working, well, you should try to invest in integrating all the different components, all the different packages, to get it all working efficiently. Another part is real-time documentation. For us, that's really an important thing that creates a lot of work. For us, it means more documentation is in fact a human interpretation of your system at a certain moment of time. That means that if your system is adopting and making changes, well, that documentation becomes history. So better invest in systems and methods to create a documentation on an automatic way. Okay, well, then another point is the overall information access. What I mean by that is you have a designer creates a new part of the installation. Nowadays, he has to ask on the engineer, oh, give me a list of I/O. Give me what are displays around, how the system works. Well, you should say to him, look it for yourself. Give him the tools and the things and look for himself. And then last but not least, we should say invest in a central information data. Stop having all your data 5 times copied in all those systems. try to integrate it, and then everything works smoothly. Okay, well, for that, I should present T-star control. Below, you see a little schema where the 5 components are placed, and we added a percentage to indicate, okay, what's the amount that can be given by the package. But one first thing is, if you are analyzing some things, you look at the alarm, an alarm is coming, then you go to your trending system, there you search the tags, try to figure out on timestamp, okay, that's the reason, and then you are working with. Well, with the T-star control and that integrated charting, alarming, operator actions module, you can all see it at one click in a button. Another part module is the alarm management. There, it's based on the EMUA 191, and there you find all those statistical parameters to give your alarms, like the traffic light chart to say how many operators are really required to treat alarms at a certain time. Then the top 10, the 10 minutes alarming, frequency alarming, and okay, in the freezing, in all those screens, you have always, let's say, how we call it, drop downs, navigation to the other functionalities and modules. Okay. Also, correlation is an interesting feature to figure out which alarms are related to each other without looking at the structure. Okay, and then finally, the whole alarm configuration, what is configured, is also very interesting to know. Okay, then you have your plant room and your control. The operators have all the advantage seeing their whole system. Well, we say, give that control room to every guy in the plant, every responsible guy. You have to take care of security, other things, but we leave that out of mind because that's not the goal. So, and for that, we converted the displays from the control room to a web-based environment, and this is an example in FoxView. These screens are populated with real-time values, so you see exactly the same as in a FoxView system. The same we did with the newer orchestra idea. So whether you have a FoxView environment or an orchestra, control HMI, both can be converted into the environment and everyone can view it. Okay, and then in the T-star control, there's also some kind of data transfer functionality between all the systems. We use that, but it can also be used to exchange data, control data from one system to another with values. Also, the monitoring is a very important part. We use that monitoring for our system to maintain everything that it works fine, but in the monitoring, there are also additional functionality to get extraction of cybersecurity logs, which will be used in Europe for their CRA NIS2 regulations. Of course, you can also take advantage of that. And then last but not least, there is also an API so that the whole central database can be exported in a way, linked dynamically with web calls to a Power BI or an Excel. Also, scheduling reports can be set up automatically so that in an email you get an attachment with your Excel report created file. Okay, another package nearly related, but we see it as a different part because the T-star control lies on the top level. The T-star pump is an implementation which is used directly near the Foxborough system. For a T-star pump, what is there the main goal? That is that you have your current CAD screen with the alarms. Well, replace it with a T-star PAM, and you have the same functionality as the actual current alarm display, but also additional information. Okay. But one important goal why a T-star PAM is very useful is that if you have a big facility with several units running, during a day, each unit has its number of operators active running. Well, in a weekend, not all those operators are required. And nowadays, as alarms are arriving to a certain station, that operator has the problem that he needs to acknowledge and click by first running from one station to another. With a T-star PAM, you can say, okay, now during the day I have an alarm page view with that unit or that combined unit. In the weekend or at a certain time, give me a complete alarm page view of the whole plant and all units. Okay. This is a look how it is, how we do that. In fact, we extract all the alarms, the same as the current alarm page is doing. We define configurably the alarm zones. Then you can define multiple alarm pages and okay, the whole alarm monitor integration. There is also operator awareness, like what is the cause, what is the action. There are additional configuration tools where you can import all those additional information to your block so your operator know at a certain moment an alarm is arriving, what do I have to do? Also from those alarming, there is a display navigation, alarm shelving, clearing, so there are all the different nice functionalities for the alarm are always also set in place. Okay, then I should say time for a demo. It's up to you.
Okay. Test. Okay, so I'm going to show you again T-star control. It is an automated system, and the goal is we created this in order to solve the problem that data isn't easily accessible in the control system. So we are here going to combine the operator action, process alarms, no, it's okay. Ah. Yes. Okay, so we're going to combine the events, so operator actions, alarms, and just the system messages, together with control system information, so the whole configuration of the system, then the measurement values for the charting, and the displays. Yeah, we will start now. So let me now show you how it works. This is just a customizable dashboard with some KPIs. And let's now go straight into the displays. So this is a display view, the Fox View version. It shows you how an operator sees it. At the right top, you can switch to the online mode, and then the real measurement values are visualized in your screen. The timestamp there indicates the time of the data values on the screen. It is a full mode, so you don't have to worry that you do anything wrong. It can do nothing bad. So you can navigate through the displays through the drop-down. You can just fill in some text or a name, a part of a name, and select the display you want. On top, the menu structure, like in the FoxView folders, is also shown. And then you can also navigate through the buttons, of course. You can open overlays and do everything like they would do and see your plant. Also, very nice feature is searching tags. You fill in a compound or a block or a tag name, and it navigates you through the display together with it indicates also where the tag is set. So now the demo opened the chart of that tag that was searched. You see here the measurement values together with operator actions and alarms. And that allows you to really dig into the history and see what happened. It can also be used for audits when you need to prove that some security actions were automatically taken by the system. You can see it in here and show it already because it had happened in the past, so that you do not have to simulate everything, but show it by the real things. Then you can also look into the control configuration. So here he has clicked on the tag in the display and opened the control browser. You can source and sync, just navigating through all the connections. For calc blocks, there are also calculation information shown. So like here, the step code is visualized so that you get immediately a visual view of how the logic works. A Boolean input and compound blocks. You can, yeah, here are some more examples of those step logics. And then we go back to the control browser. So more control information about that block. So he's now navigating to the analog input block, shows the I/O, he shows the control parameters, the configuration value, but also the live value. And then the process alarms, the operator actions of that compound block, and even the displays where it belongs, where it is visible. So that is a quick overview of the configuration. There are even more configuration possibilities, like seeing which I/O points you have, how many there are in use, and how many free items you have. So now he opens an FBM with 5 in use and 3 free I/O points. You get each compound block are linked to it. You can indeed, again, navigate to the control browser. And so the goal is that everything is connected with each other, and you can always navigate from one page to another if you are digging into a certain tag. Then another thing, very interesting, is a comparison of your control parameters. So it shows you the live value, the configuration value, and even the edited value in the IDE. Now he is already showing the management of change options. So I'm going to stop it. So what we do daily, we collect all control parameters. That's one. And then we are daily going to compare it according to your latest state. And then in the management of change, you get a whole bunch of history from all your control parameters, the live value, the control configuration value, and then the edited value that is not yet deployed into your control system. And in this way, you get a real historic view of everything what has happened inside the control system. Okay. Then that was so here, yeah, we are filtering on changed values of a set point. See all your set points that have been changed. Okay, the other part are the alarm and events. So for example, these are examples, the process alarms history. So one line shows the life cycle of one alarm. So an alarm is up, then then it is acknowledged, for example, with the duration of the acknowledge, and then the return with the duration of the return. Even the devices, the device groups are also listed in this history table. Again, navigation is provided everywhere. In every table, you can open the chart or the control browser to understand what that alarms means or where it comes from. And then also needed for auditing is the automated standards, the statistics, the EEMA 191, the traffic light chart, the alarms every 10 minutes, like Lieven already said. also, yeah, very interesting. For example, for your fire, how is it called? You, fire assurance to diminish it. Yeah, show that your alarm rationalization, yeah, is good, and yeah, so, these reports give you that. Yeah, and then yeah, a whole bunch of reports that are standardized, so you can quickly work thing how your plant is doing, what should be memorialized. Then you can also go to your alarm master settings. That is also needed. Settings list of the alarms with the parameters of what you really are your standards inside your plant. They can also be defined inside the application, and then you can get again a comparison list of your master settings, the control, the live values. And then he has now opened an alarm, yeah, a tag with many alarms and operator actions. So yeah, again, a view of that to get to see how the process evolves and what it does. Yeah. Okay, we are going back. Just a quick view of the operator actions. Here you can see it is filtered on the set point. So here you can quickly see what the operators did, how many set points did change, which tags are the most changed by them. A lot of information out of it if you look at it. And the alarm, the master alarm database management is also a hot topic nowadays. To see your settings. So here you can fill in your new settings in white, and you see the current configuration settings in gray. And so you can see if they're equal, if the control system has already been updated to your settings or not. So yeah, I hope it can reduce your time in searching to in different things. So yeah.
Thank you, Ilse. Okay, well, I should finish with just, if you have any questions, just I should say, ask one of us, and we are happy to give you all our knowledge so that it can be a part to you. Okay, thank you. Questions?
All right, is this working? I can't hear it. I hope it's working. All right, ignore the you might be an unk if jokes. Is that better? Working now? I'll let Matt turn it up as needed. Let me get the right PowerPoint up. All right. Thad talked a lot about the FTC 280. So this is a little bit of a deep dive we set up in our lab. You can't really see it very well on the table. If you want to see it outside later in more detail, we tested out using Ethernet IP, the implicit IO custom driver, as Thad pointed out, in our lab with several devices. So today, first I want to talk, because I didn't, and I doubt many people in here understand explicit versus implicit messaging, unless you had a reason to know in the past. So quick, really basic intro into that, just so you can follow along. What are the advantages and disadvantages? And then specifically talking about Foxborough's implementation, what it's capable of doing and what its advantages are. Go through the basics of the setup. There are a couple steps that are different than other FDSI setups we'll go through. And then I've got a quick demo. I'll do it for the PowerFlex 525, but we've got several devices working right now. And then wrap up with questions. I don't know. Yeah, I think you guys can all read that. So implicit IO driver implies that what we have today with the FDSI and what we've all used is called explicit or class 3 messaging in Ethernet IP. So it's called explicit because every time you want to get a tag value, you're explicitly saying, I want this tag value. It responds with a value. So there's a lot of repeated information passing back and forth. We've all seen, if you've used this driver in the past, long tag names make your driver slower because it's passing the tag name every time it reads it. That's not 100% true with the newer driver on the FTC 280, but in the FDSI it was, and it's somewhat true even on the newer driver that it's passing information repetitively that it doesn't need to be. And then, yeah, class 3 is typical. If you know Modbus, it asks for a value and gets a response. It's on a polling every 2 seconds. It asks for the value and gets a value. And as we all know, that's only works with control logics in the book, but it also works compact logics. It's only PLCs that you can talk to with today's driver, even though implicit's been out for a while. So implicit, or class 1, if you're reading the Ethernet IP standard, it's called implicit because there's some implicit understanding between the FTC or whatever the scanner is and the field device or the adapter. So when you first connect, they pass some information back and forth about what information they're communicating. And then at that point, as you can see in this comic, they're just passing the raw data back and forth. They're not repetitively asking for a tag name and getting a value back. So it's more efficient bandwidth-wise. It's not passing as much redundant information. If you're familiar with control logics, it's at a polling interval or RPI,
that it just sends the information because it knows it should send it every 500 milliseconds is the default. So in this way, it's not a polling, request and response format. It's more of a subscription. You subscribe to this amount of information you want to get, and the drive would send it to you every 500 milliseconds. You would send your values back every 500 milliseconds. You will also hear implicit called IO messaging, just informally, because if you've got a Rockwell drive in your IO tree in your PLC, it's using implicit messaging for the efficiency and the time sensitive nature of it. And the big thing here is that that's what allows us with this driver to talk directly to a drive without any PLC in the middle like we have today. So brief summary, on the left here, the advantages of this driver, the things that it allows us to do is to talk to really any third-party device that uses Ethernet IP. We've got a couple drives and starters up here, but it opens up flow meters, any kind of transmitter that's Ethernet IP, drive starters, transmitters, valves potentially, anything that you can get enough information on to configure it essentially. So in theory, there's probably some applications where you have an interposing PLC, as we typically call them, that's only job is to pass data from the DCS to the drive. And then IO messaging or implicit messaging is just more efficient. There's less redundant data being passed back and forth. And I already told Thad, congratulations, because these next three items I had on here to say are shortcomings or limitations of this driver, and all three of them are on his roadmap for this year. So good job, Thad. Foxborough is already fixing the issues I had with this driver. But the current limitations they should be aware of, there's no concurrent drivers. This is a custom driver. So in the setup process I'll talk about, you actually have to load a custom image into the FDC 280. So you can't do Modbus and implicit Ethernet IP right now. Usability, we'll go through the setup process. It's not simple. There's a lot of DevOps. We all hate setting DevOps. There's a lot of that in here. And that already mentioned, they're going to build that into the configurator to parse an EDS file, which gives it all that information instead. And the biggest thing right now is it's only simplex, meaning you can't use fault tolerant FDC 280s. Again, that was one of his things on the roadmap for this year. And I'll just point out one very could be confusing thing with the documentations. There's two versions of this driver, and the documentations are named backwards. So there's a document for the quote unquote scanner driver. That is not implicit, even though scanner is a implicit IO term. That is just the normal replacement for what we have today, explicit messaging. And then the introduction, it names it correctly. It's just the title of the documentation is swapped. What you're looking for is what it calls the client driver, which is not an implicit IO, implicit messaging term. That's the one you're looking for. In the introduction, it mentions that it can support implicit IO to 256 devices, or explicit as well for some reason to one PLC, which I didn't put that as one of my limitations, but that's the other one you're working on, is multiple PLCs. So that's just, I'm not going to spell out every step in this presentation, but the process in that manual works. You just got to make sure you get the right one. So setup and installation, really high level. You're installing a maintenance patch to get this driver because right now it's a custom driver. And then once you do, if you're familiar with control software, there's a step to import a driver definition file. Again, those steps are called out in the manual. The one I really want to draw attention to, because this is a custom driver, is in the user Fox SP files, maybe I got that right, where all the drivers are stored. You have to rename, you have to run this batch script, which takes the image for the FDC 280, moves it to the side, and moves in the custom image, then do a major image update, and then run one to move the driver images back. I feel confident saying that with the release of the non-custom driver, that step goes away. So at that point, you've got the driver installed on your system, and you've got to configure the ECBs. Again, manual covers this pretty well. I think my next slide. Yeah. So you've got the ECB 200, just like you normally would. It tells you what driver ID to do, and you're using the custom parameter 1 implicit. I think the other option is Ethernet IP, but you're telling it you want the implicit driver right now. And then each adapter device, that's your drive or your flow meter, every device you want to talk to, you've got an IP address, obviously you need to configure. And then these DevOps are the ones that are talking complicated, I guess, or tedious. And especially without the EDS file support, it can be hard to figure out what these values should be. A little close-up image of, if you're familiar with Rockwell drives, this is the window of just a generic Ethernet module. It's the same information that Rockwell needs to know to talk to their own Ethernet IP devices, but it's DevOps instead. So just briefly at a high level, you've got the COM format, so that's the size of the parameters. Is it 2 bytes or 4 bytes? And then the big things is you've got an output and an input assembly. This is what tells the device, the adapter, what information you're going to pass back and forth. So output assembly 150 in this example, and the size, the number of output parameters is 4. So in my foray, I found this to be either really easy or impossible to find. Most of these devices, their manuals had information on how to set up for Ethernet IP. If you can find a step that shows you this picture, you're golden. If not, you got to look through tables and kind of figure out, they may call it the configuration assembly instance, they may call it something else similar. Hopefully that's all automatic when we get the EDS file parser. But this is really the key to making it all work, are these DevOps. So we've got our ECBs. Next you do the blocks. I'll skip most of the details of that. We've all built DCI blocks. The big point is that when the format of those assembly instances, you've got X number of parameters, and your point number is going to be some name that doesn't matter, by the way, as long as it's unique, colon, the parameter number. So like, I think I grabbed these from the manual for a PowerFlex 525. Drive status :1. Drive status there doesn't matter at all. It has to be there, it has to be something. If you put the same point number in 2 places, it'll complain. But the :1 tells it's the first parameter of that assembly instance. So again, this is where you're in the manual. Hopefully the EDS file helps with this, but you're in the manual looking at tables to figure out what order the parameters are in and parsing it out. And I just put a note here is the manual itself uses an integer in block for frequencies, integer out for the command frequency. With PLCs, you've probably seen that's usually multiplied by 10 or 100. So RIN block is better for that. The manual, you have to pass in times 100 for a PowerFlex 525. Whereas if you use a route or a REN block, you can use N gain for the same thing. So just to show, briefly go through this live demo. Hard to see from there. If you want to see it on the table later, let me know. We've got an FTC 280 talking to a TSYS-T motor starter. So TSYS-T motor starter is Schneider, if you're not familiar, using Ethernet IP. PowerFlex 525 drive, obviously Rockwell. We had a 753 in the lab. I did not bring that up here. It also works. And E300 motor starter. The parameters for the PowerFlex were in the manual, the TSYS-T and the Allen Bradley E300. I had to parse through the manual and figure out myself. Oh, we're streaming live. I told my daughter Lori I would say hi, Lori. Oh, that resolution's weird. Hopefully that doesn't mess me up too much. All right, this is not a great screen, but I laid it out this way specifically so you can see for PowerFlex 525. On the left here, I've got our inputs, so things we're reading back from the drive. I doubt any of you can read these on the left, but those are all bits that I got from the manual. So drive status is an integer and all the bits have different meanings as we're used to. Output frequency is going to be the actual frequency of the drive that it's feeding back. Data links 1, 2, 3, and 4. If you've used Rockwell drives, that's basically, you could put what you can configure what value comes back on data links. And then on the output, we've got the command and frequency here. And then output data links. So I mentioned the point name. If you put data link 1 there, it will complain about a duplicate point number. So that name here, even though it doesn't have to be data link, it does need to be different from data link. Anyway, one big part of this you're probably missing out on because of the size of the room is you won't hear the drive kick on probably. But just an example, logic command, if I hit the start, well, before I do that, if I give it 15 hertz as a reference frequency and then hit start, those of you in the front might hear it click on, and we get a frequency back. And then which one does it stop? It's off, 0 feedback, and there's a jog, which is so nothing crazy there, but that's Ethernet IP talking directly to a PowerFlex drive rather than having a PLC in the middle. And for our demo, I won't go through each of these, but we have working examples of an E300 and a TSYS-T motor starter. All right. I think I'm doing pretty good on time, right? My taskbar, so I don't know what time it is. That's wrong. Yep, 15 minutes. All right. So supported devices, again, I said any Ethernet IP device should be supported, assuming they correctly implement the standard. So just some examples of ones that I've seen work or that are in Foxborough's manual. Everything I set up here, the 525, the 753 in our lab, the E300 motor starter. They've got a couple in the, I can't read that any better than you can. They've got a couple in the manual that I'm not familiar with, but are listed as supported. Is a WEG frequency inverter, the ABB universal motor controller, and the PSTX soft starter. And then we've got the T-SysT up here working as well. But, you know, like I said, Micromotion, ProMass, anything that has an Ethernet IP interface should be supported if you can figure out the right DevOps. And that's it. It was short, sweet. I welcome questions, or if you want to see anything. We got plenty, we got at least 15 minutes of time for questions if you have any. I can try. If it breaks now, it's fine.
Management module, talk to multiple customers.
T-SysT motor man, that's what this is, right? That's what this is called. Yeah, I'm not sure what you're talking about. So it's one that manages multiple buckets? No. Yeah, so a T-SysT goes, like every bucket would have one of these, and they all have their own IP address. Yeah, I'm not sure what device that is, but no, I haven't set it up. What devices do you guys think you, besides drives, I think that's the most obvious use case. What other devices would you guys consider using an FTC 280 to talk to? Yeah, weigh scales, we've, yep. Yeah, a lot of things that today we're using Modbus for could be Ethernet IP. In theory, that's more time sensitive, the Ethernet IP protocol, for the same reason I mentioned class 3 is more like Modbus. Class 1 is more reliable on getting an update every 500 milliseconds or 1 second, whatever you configure. All right. Well, if we've got no questions, I think I'm the next person too. And that one's even faster. So Dave's gonna have to fill the schedule or give you guys a break. This is pointed at, this is Thursday, there. So the next one is, I call it a quick tip, and I mean really quick. Get out of this presentation. Go into this presentation slideshow. From beginning. Nope, not that one. That's tomorrow. I'll start while I open this with a show of hands. Who thinks they know and understand what the change delta parameters do? Dave says yes. All right, had this open last night. Give that guy a break. Speaking of, I gave you a hard time of not being able to find anything on OneDrive, Dave. Well, joke's on me now. There. All right. I'm doing this presentation very quick because I've seen just 2 months ago, I went to a site and they had an issue with the control loop that they couldn't, I won't say they couldn't figure it out. I don't think it was the operators were asking for it and anybody had spent the time to figure it out for about 5 years. And it took me 5 seconds to fix. And it was all because of this change delta parameter. So took this first part from the manual. It's just a real value that defines the minimum percent of the input range that triggers change-driven connections for parameters, and this is for a PIDA block, so real input range 1. So what does that mean? Change-driven connections, for us, that's essentially peer-to-peer connections. Delta parameter does not affect connections in the same CP at all. And then the other call out I have here is that delta O1 parameter or delta I input 1 parameter. Those are percent of scale. So the default value is 1. If you're 0 to 30,000 GPM, that's 300 GPM before it even messages the change over the network. So said I'd keep this quick. Here's the example of what I saw. It's that simple. For whatever reason, first off, don't do this. Obviously, don't break up your control loop into multiple controllers if you have any control over that. In this case, I believe for whatever reason, electricians probably, the input and the output were in 2 different controllers. And what they saw is that this controller, it wasn't flow controller 101, but it was a flow controller, wasn't responding until there was a huge change. Huge is relative, right? It was set to 1%, but their scale was so wide that they were operating in like 5% of the range. So number 2 thing, don't do, scale your transmitters, something reasonable. And all it was is their delta 1 defaulted to 1, which was, I made up 0 to 300 GPM here. It was more than that. Again, I would put those in the same controller if I could rewire stuff, but instead, all I had to do is change the delta I1 parameter so that it was updating more frequently. So 0.1, I think is what I put in, or 0.05, so that it's all small changes in the measurement. Because, you look at a trend, FT101 was bouncing all over the place. FC.measure was flat, and then you'd see a jump of 4.5. And you'd see a jump. And then the controller would react, overshoot, and you'd see it drop down. So, quick tip, it's not anything we probably didn't know, more of a reminder, is to make sure you look at those and make sure that 1% of your scale is meaningful, especially in cases where it's a analog value that you're trying to control. All right. Couldn't be any quicker. Yep. To your point, yeah, to your point, over the node bus, which I think I have, you might be an unk about the node bus. Yeah. There were a lot of considerations, right? That's why these change delta parameters exist, is to limit that network traffic. So, you know, it's less of a concern, but it is still, you know, I'll counterpoint myself is by I wouldn't just say put 0.01 on everything necessarily, but, you know, make sure you remember to think about that 1% if that's valuable or not. Right. Yeah, for anyone who couldn't hear that, for the block parameters, like in this example, it's in percent of scale, but let me just back up and say these deltas exist in object manager lists, so which are nebulous to most of us. You might be a little bro if you have no idea what object manager is and you're afraid to ask. But essentially, it's a source, a destination, and an amount that it considers, you know, the change delta. So in the block parameters, that percent of scale gets downloaded into that object manager list. It can be weird about if you have multiple points. I specifically didn't get into this for this quick tip because I didn't know the answers or time to do the research to find them out. I don't have two CPs up here. But to Ricker's point is that it's percent of scale for the block parameters that I was showing here. In AIM star, it's in engineering units. Yeah, Foxview Foxdraw, when you configure that, that's another one that I think we're used to. If it's not updating on the screen, we're used to going to look at that and change, you know, decrease the delta value there. Thanks, Ricker. All right, Dave, I don't know what's next. Talk to the audience. Has anybody filled out their note card? Take one back to myself. Yeah. You're good.
Okay. So the question was, are there any plans, developments with system advisor, specifically improvements with warnings that the collectors aren't bringing in new data? No.
Can you hear me now?
Yes.
Very good. So the answer is I don't know because I don't look after this product, but I can ask the person that does and let you know. What I can say on a very high level is that we actually invest quite a lot into building a product that follows System Advisor at some point. It's not ready yet now, but I've seen early previews. It's based on a different concept and on different technologies and on different use cases, but it addresses many of the System Advisor use cases as of today. But it will definitely get away from having to script all the data collections manually, which is one of the pains of setting this up.
Right.
But I can ask the question and get back.
Okay. because that is a thing that we have seen. You know, it doesn't, you don't know that you don't know. You have to set up almost a tag to go, oh, if you, I should have seen this update every day, every
Right,
4 hours. And then you look at it and say, oh, it hasn't updated. It doesn't let you know it's not working. What's that? Yeah. You could, yeah, it's been 4 months. It's been a year. I don't know why this isn't working. Okay. Well, I mean, while we're, you know, killing time, well, let's not kid ourselves. Do any of you, the users, have any control issues that you are unable to solve with the control blocks you have available today? Do you have a control problem that you cannot solve with the toolkit that you've got available to you? That is, yeah. Yeah, they're going to do that right after they put the PNT parameter on the RIN block. Yeah, but yeah, that is a problem that they don't have as good a timing on some of those as we would like to be able to. Well, here's another one back for you. If you don't have any problems with any of that, and this is back to the users, what applications have you found for AI where it works well and where it has disappointed you? This is specifically related to your control systems, not just the Foxborough system. Anybody got any use cases for AI? This would be, you know, where we're taking stuff and we're sticking into Chat GPT or Grok or whatever. Yeah. Yeah, it is very good at reading a manual and answering a question based on a manual. That I've had good success with that. So that has turned into a positive, you know, going down through there and you just shove a whole bunch of manuals into them and then say, how does this, you know, how does this supposed to work? And get, what would you, did you say, Ishmael? Right. Right.
I'll say that one was probably very good at that one because the manual pretty much has a step-by-step process. If it had to, yeah, if it had to really correlate different data, I'm not sure how good it would a job it would have done. Maybe better. Maybe it would have been fine.
Mm.
Yeah, I definitely know some little bros that use it instead of Google. We don't Google things now. We chat GPT or Copilot things.
Yeah. Yeah. Scott?
I didn't have the process.
Right. Right. And I think we're going to see a lot more of that in the not too distant future where they're, yeah, Ishmael? Belgium, you know them.
Yeah, let me talk a little, draw attention to that a little bit. That's one of the use cases I've seen multiple places is this concept called a virtual sensor, or which is what you're talking about potentially, where you've got a bunch of process data, whatever you think might be related. The example I saw was a bunch of temperatures and humidities in an oven, and it was predicting what your quality would say for a cookie or a cracker or something. But you've got to then, after the fact, feed in your quality results and map those to the right process time. Yep. So it's definitely training, and I think for us, what that ends up looking like is it's our job to figure out how to get them like the data out of our system, because they don't know Foxborough, they don't know any control system, right? They're all data scientists or whatever. Yeah.
All of that.
Yeah.
Out. Looking at spirals off. Modeling on that. I'll take in area over the file move. Was anything was happening there. Guideline.
Yeah, so that was AIM historian and using. Has anybody here used the OLEDB interface to AIM? That's what Arlie used for that, scripted out to basically query the AIM historian like it's a database. So he's like, give me tag values from this tag between these dates, and dumped it into a CSV file.
Oh, I can imagine. Yeah, every time a valve moved over a year, yeah.
Yeah, and I went through this.
Yeah.
Yeah, go ahead.
You gotta throw it. Yeah.
I'm not going to throw it. You can walk them. So a thing that irks me about the machine learning stuff like that is that, at least the ones I've seen, which are specifically Logix AI and some Python stuff, is like you're always looking at one point in time. And I know like a lot of the multivariable loop tuning stuff, you've got, if you see a spike 10 minutes ago, that's affecting your value now. We know that's how it reality, right? You've got like an impulse response, and like a lot of loop tuning software that has multiple variables has like a transfer response. And all the Logix AI stuff, or all the AI stuff, Logix AI is one of that I've seen used. It's only looking at snapshot in time. There's no, it's looking back at what happened 3 minutes before your talking about. I'm not going to say that it's not possible to do that, but I haven't seen anybody that's doing anything more than looking at 50 different values right now. So yeah, AI, this kind of virtual sensor. What was the other term used? Differential or something? Okay. Yep. And what I've seen, the output of that is you give it a bunch of data and then you get some polynomial equation that it thinks should correctly predict your value, you know, which could be something that got entered the next day from the quality lab. You know, if you're taking a sample every 15 minutes, I don't see anybody.
Got a hand up over there.
Ah.
Mm-hmm. Right. Any bit. Any bit. MU bit. IMU. Yeah.
Yeah, and it's, you know, the Python code of it is pretty straightforward. It's like you give it a CSV file with a bunch of data, you run like 3 or 4 commands to kind of condition the data, right? Like if you've got linear interpolation between those 2 points or whatever. And then it's like dot train, dot predict. Now, yep. Yeah, I think we'll see more and more of that agent type. That's going to be one of the big pillars of AI integration, is being able to just ask a question and get answers. There's a lot out there that's, I'll say, burgeoning on that front. So yeah, like virtual sensors, AI agents. What was the
Data,
yeah, it's
data,
all data.
data.
The other
Yeah.
one the other is like anomaly detection. So looking for abnormal conditions, you train it on what it looks like when I'm running, and you give it a bunch of data, and it's constantly looking for some sort of anomaly. Hey, this air compressor amps are going up, that kind of thing, and drawing operator attention to it. Yeah, do you mind if I talk about what you guys are going, or your goal is, or is that like a strategic? I mean, do you mind if I say it, or do you want? Okay, so some companies are looking at reducing operators, and you've got some use cases to base this on where they've already done it, that they're replacing operators with AI. It's more of like, just have maintenance people that go look at things, because again, like Dave said, your AI is not going to fix a faulty transmitter. It may point out to you that it's about to fail next week.
Yeah.
Out there and actually do the work, but it will keep somebody from ignoring it for 6 months until it completely fails, and then it shuts down.
So in a few years, you'll be talking about that up here, right?
Yeah, I did what Christian said and put in Chat GPT. He said, based on last night, what should I do? And it said, go to the bar and start drinking. Not good. That's your, if that's what it tells you to do first thing in the morning, that's not a good thing.
I got a question, Dave.
Yeah, go ahead.
Everybody. So we have been asked by narrative.
Oh yeah.
System model would be great.
Yeah.
But right now, all we have to do is find comments. But each time you make a change to that controller, you have to go back in there and change the comment.
But you can take, I mean, you could basically take an ICC print file or whatever, dump the stuff out and have it document.
Yeah, so
Pretty.
yeah, so first I think you guys have a policy that you can't upload anything to an AI engine, I think. Not just, which just means you can't have like Chat GPT. So I think that option is out for you guys, but for other people, you can upload like a sequence file or an ICC print and ask it questions. Now, trust but verify, don't even trust it. You know, with anything with AI, especially, you know, where we're at now, it'll confidently make up whatever it needs to answer your question.
Right. 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 And say, this is what it does. This is our control narrative.
I think you could definitely have it take an ICC print and it'll get you everything, but you'd still have to like check it and make sure it's right and look.
And then if you could take screenshots or whatever of the stuff that you have into the control editor, it can decipher some of that now too. I mean, the parts it can read, it's kind of weird.
But yeah, that's an interesting idea for system what are they going to call it next? System analyzer, I think is the next gen.
Yeah, whatever system. Yeah. So Roger, what do you got?
Do it. Fox Ray, system auditors should describe it.
You can go in and add comments. There's a comment section, but you have to type everything in. Right. Once a change is made, you have to go take the comments.
I mean, it would be a win for us just to have an as is. We don't have to spend the next 5 years writing Word documents. Right. That's what it's looking like right now. They want us to type out everything in the site forever to do. So even if we just upload something as is, then it doesn't go.
I'm sorry. No. Okay. That is so weird that it does that. Come here for a second. No, no, him. Not you. Not, yes, you're in trouble. How does this thing keep doing? How does my computer keeps doing this thing where it's like, one, I don't know how it got in this presenter thing, but display settings maybe. But the other thing is that's fine, but when I try to go to my other, I duplicated my desktop. Well, why did it unduplicate? It unduplicated.
Yeah, you get 20 seconds.
I thought I hit that.
It's,
Are you sure? I'm sure that's what I did.
You can also hit it.
Swap screens? That's swap screens, but I'm only, it's the same screen, right? So now, okay, hang on. So I want to minimize this guy. I want to show this guy. Okay, and then I'll go through. Okay, I'm ready, maybe. Oh, I want this clicker too. But I'm gonna have to come up, yeah, it can be. I know how to do this. Thinking maybe. It's in loose, isn't it? But I don't think that's the, oh, there we go. Lucky me. All right. Okay, thank you, Matt. Okay, we're good, ready here. We'll start back any second. So round them in, we'll get them going. We'll do another 30 minutes, and then it'll be 3 o'clock, and then we can just talk about things that are of interest to you guys. And we all go to the hotel and get ready to go out tonight. That'll be great. All right. So this one is being able to run display manager commands from sequence code, right? So display command manager commands, probably most of you, if you've done FoxU, Foxtrot at some point, you've had to do a display manager command that does a DMCMD toggle or something, and that DMCMD is display manager command. That's what they're doing. So, well, that's fine. And you can put buttons on a screen to do all this stuff, and that's okay. But we want to be able to do this programmatically from sequence code. We don't want to have to be pushing a button on a screen. We can do this for them. We can do this for them. That's what we want to do. So we'll go through that. Who am I? I've been up here all day. I'm David Johnson. I'm with EOSys. I've been doing Foxborough stuff forever and ever, and been involved in this users group for as long as I can remember. So we're going to go through this one. Why would we want to do this? Why do you want to be able to write a piece of sequence code and do a display manager command? Well, one, it's fun. It's fun because the operators don't know what's going on. This is the best thing ever. Like, just things happen. It's like things happen in their life and they just have to live with it. Years and years and years ago, before I was here, I was at a company called Globe Manufacturing. And at Globe Manufacturing, I was the controls guy. I was the only controls guy at Globe. In fact, Mike Judon came over and toured our plant before they got their first Foxborough system. I was over in Tuscaloosa, Alabama, and I was young at the time, not like now. And so one of the things we would do is I would just find things to do, right? We built the plant, and then we're looking for things to do, and so I was doing stuff. And so like one year we had spinning cells. We had the spinning cells. It's a polymer process and they come out of the spinning cell. And so each cell was a little circle and they were either red or green. Okay. And they were numbered 1 to 80 and the operators could use them. So it was, getting on in December and I thought, these things look a little bit like Christmas tree lights. So on Christmas Day, I had all of the spinning cells arranged in the shape of a Christmas tree, which was really hard to find the one you were looking for, but it looked really cool and looked like a little Christmas tree and they would turn red and green and all of the little ornaments on it. So things like that. Or, if it was between midnight and 5 minutes after midnight, I had a little piece of text that was almost exactly the same color as the background that would flash that said you were getting very sleepy. And it would flash real slow for 5 minutes and then that was it. And that went on for a long time before an operator came in and goes, "You're doing this to us, aren't you?" Maybe. Well, this is a fun way to do other things to the operators. So think of all the fun you can have with this. So, well, what does it do? Well, all of our display manager commands are at our disposal. There's a whole book of them, B0193DF. I may have that up, I may not. But you can do, you can open overlays, you can set protection classes, you can enable and disable OM sets, you can, whatever you can think of that they can do off of there, you can do. And because you can do it programmatically, now we can do some fun things to them. So I built a little screen doing this, and then I will show you how it does it. And these are not really very useful examples. And then I built one that is a little more useful example that kind of shows you what you could do with it for in a more real world type application. But you can think of things that you will do. And I'll come up with a few where I show you some things we did. Okay, so if I do that. Do that. Go back. Let's see. We go. Oh man, I love this. Previous. There we go. So we want that. Go here. Okay. So what do we got? We got a little display we built, and I got a bunch of buttons down here. Well, these buttons, instead of being things that are going to a display manager command, like you might think, they're not. They're going, if I hit this standard display button, you'll see that I got a piece of sequence code running and all of those buttons are tied to Boolean inputs on this piece of sequence code, okay? So everything that a button does doesn't have to be done from a button. All of these can just be an action that comes into the sequence code. So the button is just there so that I can do a demonstration. You don't need them. This is us able to run it from behind the scenes. Okay. And so the code in that, this is just real simple. I've got this, but if you look, each AW and each display manager has a piece of, in sequence code, has the display manager name. So we have AW7001 DMCMD. That variable just exists. You don't have to build it. You don't have to do anything. It's just there. Okay. It's part of it. That's how this thing is reading the display manager commands that are coming into it. And so when we put the little piece of text on the other side and it tells it what to do, you can make it do things. So these are available to you to do different things with. And so we'll go and hit a few buttons and see what it does. We've got a demo one. Okay, the first one says change the display after 5 seconds. So I hit the button for 5 seconds. We go to the initial display. I can pick any display I want, and it goes back to our screen. Now, not terribly useful, but you don't have to go back. You can call up a screen on a display based on an action that's going on in the plant. Something happened. I want the operator to be on this screen. I make it go to that screen. It just happens. Now, I can do it one time. If I one-shot it, he can go back to wherever he wants to go. He's not stuck on that screen. I just put him on that screen. This event occurred. Call up that screen. Let the operator take over. I'm not going to keep messing with him. I knew this was somewhere he needed to be. He needs to deal with it. We do that. And so that's a thing we can do. Again, because this turns all this other stuff on, you get things like up here at the top, we have the alarm bar with the system and process thing. So we can turn that off. Goes off the display completely. We can turn it back on. I hope, yeah. You know, we have the ability to write things up here into this little message line. That's not terribly useful on the new stuff because those tend to just have little weird things on them, like what time it is and the last thing called up. But you can, I mean, we have the ability to put things on that. So I got here, it just says hi to the message line. So if we click that, we're going to see that up here. See, we get the date, time, and then it says hi. So we just put that up there for you. That's like not very useful. But this one we did open an overlay. This is an overlay. You press it. Well, when might you want to do that? Well, and when we were working at International Paper in Cortland years ago, and they had a emission monitoring system, and if they got out of whack on their emission monitoring, they were getting a fine of hundreds of dollars a minute. And this, like hundreds and hundreds, like $800, $900 a minute for this thing to be in an alarm. So what they did is they said, we need to know that the operator saw the alarm. It's not enough to just alarm somewhere or have it on a screen. So what they did was they had every one of the operator displays pop up an overlay that said, you know, we're out of compliance on our emission monitoring. And it had just a button that said, okay. And somebody had to hit that to get back their screen. So every screen that the operators had, it came up on all of them. All of them could turn it off. The first guy that hit the button turned it off for everybody. But it forced them to go. And then the next morning when they come in, they go, okay, we were out of compliance for an hour and a half yesterday. Who hit the button and knew we were in trouble? Which one of you guys, you know, acknowledged this and didn't go fix it? So we were able to do that. So things like that. So there are uses. That was a very practical use of this, is that we forced that and said, you can't do anything. This is priority over everything else until somebody does something. Okay. And then we have the standard display. We showed that. And then the display bar down the side, we have the ability to turn that display bar off. Just the screen space on the side, or turn it back on. Now, again, I show this simply to show you that all of that stuff in that book is available to you. This is a sample. This is not everything you can do. It's just, you can make it do any of this stuff when an event occurs or when you want it to. You control that, not that. And if it's in the book, it can do it. So the next part is a little more practical, a little more something that you might actually find a reason to do in the real world. So this is a similar type operation. Now, I made it a little, you know, obvious for sake of demonstration purposes. But what we have here is we have a sump pump, let's say. And if they treat this, they can send it to their sump treatment. And then if they test it and they know it's okay to send to the sewer, they can send it to the city sewer. But you can't do that unless you know that this is not going to be an environmental problem. So they have to have tested it. So what we got here is we got a system where when we hit a high level, it's going to start the pump, and it's going to pump out to the treatment. Okay, and so the pump's on, the valve's open, it's pumping out. The level would be going down in a normal type situation. And when it hits a low level, it's going to turn that off, which gets out of the alarm. So we can set the level to where we want. So let's pretend the tank's draining down like it's supposed to be. So we're coming down. If we get down to 20, it turns everything off. So that's what we want. That works like it's supposed to. Everything is working well. So let's go back up and say, okay, we tested this. We've got a sump situation, and the operator wants to also, because I'm not going to turn off the treatment, but we're going to go to the sewer. Okay. Well, I've got a button here that says open, right? So, but I've also got a allow the operator ID, enter your operator ID to allow the city sewer valve operation. So I'm hitting the button. You can hear me clicking, so I must be trying. I'm hitting the button and it won't open. So that's an example of, okay, so what are we going to do? Well, this is useful. We enter the operator ID, can be anything you want, because we got it behind the scenes. We just made one up, and this operator enters his ID, and now he opens the valve. Thank God it worked. Okay, so the guy entered the ID and he opened the valve. And you're like, okay, cool. That's not that impressive. He entered the valve and he did his thing. So, but notice that what we did, anybody can close it, by the way. There's no protection class on the close. He comes back, he wants to open it again. It's a one shot. He's got to enter his ID again. We are forcing that to be re-entered every time he opens that valve. He can't just get it. So it's not enough to say, I entered my ID and I got it. It's a one shot, but it's even better because unlike if we could have done all this in controls, we could have done this behind the scenes. I could have built a calc block to give us a one shot that would have kept that guy and say, okay, here's my ID. I checked it. Yeah, he's got it. But when we do that, it opens that up on every screen that's looking at that. This is only affecting that protection class for the screen that I'm on. So if they had this same exact display pulled up on a screen next to it, and he doesn't enter his operator ID on that screen, he can't use that valve. This is not the same as just setting the one shot. This is saying this is valid. This is a protection class. It's set for this screen, not this environment, this screen. And that guy can only do it. And then after it's done, he's got to tell me again that he really wants to do this. And these are things when you do that, when you really care about letting those guys have that. It's like, I trust you, but you got to be 100% sure that this is what you want to do. And if it is, it's on you. And by the way, I recorded your operator ID and I know that you turned it on at this time and that valve was opened at this time. And I know operator action journal, and I can now go back and say, I know what screen it was done from. I know what operator entered the ID. I know what time the valve opened, and he has to do it again the next time he wants to do that. It's a one-time credit that he gets, and then it's gone. And you can clear it after a few seconds too, which I didn't, but I know how. So you can say, okay, if you enter your operator ID, you're good for 10 seconds to open that valve, and after that, you got to go back through the enter process again. So you have a lot of control over that particular button. Okay. Yes. And that there are some caveats in all of this stuff, and you can do that, but you can get it on number one. You can actually have exception handlers that know what screens are available, so you don't have a problem. I know that I can do that. And you can go even more and say, okay, I know that I'm good. I've got my exception handler in. And then you want to test all of this stuff very thoroughly to make sure that, it works like you want before you don't. Because when I was doing this and I was building these and I was showing things, well, one of the things I did was I did a disable operator sets, which were great when I hit the button. And then I got another button that says enable operator sets. But if you disable the operator sets, you cannot re-enable the operator sets because now I turned it off. So that was, so I had to wind up, restarting FoxView and getting it back up. And so that was a hassle. So yeah, I mean, turning these things off, you got to be thinking about what you're doing when you do it. But it's a good thing to do. And it's valid, meaning that this is not some, crazy thing that somebody's like, why would you do that? But you need to be aware of what you're doing and why you're doing it. So yeah, that's just a little example of what you can do. And then if I go back to my PowerPoint, I think I'm out of sequence with it. That's okay. So if I go play from here, It's so weird that every time I go to my VM and come back, it changes my screen resolution on this thing. Okay. So we did that. So these are the things I did the first time. We had a call up and change back. We hid the alarm bar. We sent a message. We did that. So all that stuff. This was a little more practical. And so we turned it, and we basically made a one shot on a 2-pick confirmation. So that's, like I said, when you really, really mean that you want that to happen. So, and we did the 2-pick in action. And so now this is what the code looks like. Well, okay, again, this is a little bigger. It was showing that earlier, but this is the ones where I'm turning the alarm bar off, where I just picked those Booleans and did it. And once they turn them on, I turn them back off so the operator doesn't get stuck. And these are all of the ones that were in it. Again, just pulled out. I did so you can kind of see what we're doing, where we're sitting, unprotecting the value and then reprotecting it. And all those values are available to us to do. So, you know, something to think about, not necessarily something you want to go run to the plant and work on immediately, but it might be something you find a value in. So that's that demo. I have another presentation. If I can. Sure, go ahead.
I've got a real world example we're working on right now. Is we've got fire alarms, tornado alarms, and active shooter alarms that we let everybody know about with a horn. But the discussion was we may want to pop up on the DCS.
This would be an excellent way to do that.
Okay, but we've got 8,000 something operator graphics, the different FDF files. How do you recommend handling that?
You've only got, all you have to do is, if you have an alarm, say a, active shooter alarm, for instance. Okay, so you got an active shooter alarm, and what you do, you don't have to, all you got to do is build one display that says active shooter alarm. And then you've got the piece of sequence code that's running that says these are the displays. If this event occurs, I hit one button, that's going to pop up on all of these displays. Okay, no. All, and I'm saying displays, and you're thinking displays. This way. Every screen, you're just telling it the Fox view that you want it to come up on. You don't have to put it on every, I don't have to list, yes, the display manager. So I only have to tell it, and yeah, you're going to have in your plant 30 or 40. Yeah, you'll have, yeah, but yeah.
8, and it's going to send it to there, and it's going to pop up no matter which graphic.
Yeah, no matter which graphic, and then the guy can just hit, I don't want to see this display, and if you only do it one time, he doesn't have to deal with it anymore. It's not going to keep popping up. So it's not so you're not really, you just paying. I popped the display, the overlay up. I popped up an overlay that says active shooter. The guy goes, that's not good. And then hopefully he hits the button that says okay and, takes cover. And then he's done. You got the message to it. Yeah, that's definitely doable. Yeah, and that's the very, very similar to the scenario where they had the emissions on the stack at IP, and they were like, this is costing us too much money every minute for us to let this go. So they forced that, but it's the same thing. No matter what display's up, you can come up with that. Yeah, and it's relatively straightforward. It's not like something that you got to really invent the wheel here or anything. Now the next one, if you think that I was an unk before, wait till you see this. Where is my work? File. Oh, there it went. This is one I want to ask the kids in the audience.
Okay. How many people in here regularly use the work volume? I noticed there seems to be an age gap here, Chris, between us and the other people that use the work volume. All right. So we're going to talk about this and the pace buffer and some stuff that is available. And this stuff's been available forever. And it's one of those things that people have like let fall by the wayside, and they don't think about it. And it makes your life a lot easier if you use it. And it gives you some nice capabilities that people have forgotten about, I think. Now, if you've gone to the FoxPro Control Editor and you're working in the new stuff, you don't really need this. You can build strategies and you can hold stuff back and everything. But if you're dealing with ICC and you're old school, this has got some handy features that are nice to have. And this is what I said, and I did this before I got called Unc. That's the funniest part of the whole thing. I said, I subtitled this A Visit with the Elderly, because nobody here is going to use this except the people that are really old. And I said, and back in my day, this is how we did it. And we liked it. We loved it. And so we're also going to pump up the volume because these are all work volumes. And so we'll show you how to do that. Yeah, I've been here a while. All right. So I asked, how many are familiar with work volumes? Not a ton. Okay. Well, what is a work volume for starters? Well, a work volume, every system definition forces you to have a work volume. You have to have one. You have at least vol work. Okay. You might have multiples, but you're going to have one. It's in your system definition. And it looks like a control processor to the configurator. So it looks like a CP, but you can't do anything with it. Doesn't run any control, doesn't do anything. It's just there. Okay. So that's what it looks like. It looks like a CP to the configuration tools. It's basically a work file without a real CP associated with it. You use it as a repository of control code snippets that you want to reuse, or you can use it as a place to kind of rough in calc blocks, sequence blocks, your logic. It gives you a place to build something before you copy it or make it or done it or deploy it. But I don't want to say deploy because I'm using ICC, so you don't really deploy. Okay, here's a quick side quest. This is another one of those deals. I want to check. I assume everybody knows this, but every now and then you run into something and somebody goes, I did not know that. And it is like, and you're going like, really? You didn't know that? Okay. If you make a new block and you make the type, normally you just say, I'm going to build a block. I'm going to call it block X, and it's an analog in. I'm going to build a block. It's a whatever, it's this. But if for the type, instead of putting that in, you put in the compound and block of another block that is already built, it will copy that block, including all of the steps of sequence code. Well, not all the sequence code. You got to copy the .s file, but it will copy all of the commands that are in there. Like if it's a calc block, it copies all the steps. It's there. If it's something else, it copies all of the parameters over. So it gives us a way to be able to move things and build things in a hurry and keep it all straight. So like here I am, I built a counter because I keep one of these running around all the time that goes like counts up from 1 to 100 and then starts over. This is just handy to have as a block on your system, right? Every now and then you want to be able to do some quick testing. You're like, man, I need a number that's always going up. Well, okay. So I keep one around. And so here I'm building it. Well, if I want to build the counter, all I got to do is go, hey, I got it in my work volume. I have a compound called template. And in my template, I keep blocks that I want to be able to reuse. So when I need a counter one, I just go to the template, copper counter XXX, which is what I've got my counter called, get done, and I've got a counter built. And it's just that easy. You can copy it from any other compound, and there's all the steps that are in that, and it keeps it available for me, and I don't have to deal with it, and it makes it easy. So, and then if you want to count up more than 100, you change step 5, and you can put whatever number you want in there. So simple stuff, right? But sometimes you run into people that don't know it. So we're going back to work volumes. All right. because there's no physical CP, there's really no system loading on a work volume. They don't take up any processing time or anything. It's a work file, and you can build as many as you want. And I think you probably ought to at least have 2 on any system that's ICC. I usually keep 5 on mine. And so I just use that for development. You can add work volumes by adding a few text files on there without having to go through a system definition, and you don't have to recommit your box. So if you want to add some, it's pretty easy. But if your box gets recommitted, the ones you added by doing these text files will disappear because you didn't put them in the system definition. That's pretty typical. And I'm not going to show you that here, but if you want to learn how to do that and you're using ICC, we can show you that offline. And the names are always lowercase, all lowercase. Vol work is one that will be there, and then they always start with, I say they always do. If you edit the text files, you can name these things anything you want, and you can put the uppercase in there. I wouldn't advise doing that, but you can, you know, so it's possible. So when I say names are typically all lowercase, they probably should be. And if you're doing them from the system definition, you're going to have vol work and vol 000 or 001 through 099 or whatever. So that's how they name them. So, you know, that's just the system definition thing. And the ICC tools like ICC driver task and ICC print, they work on the work volumes just like they do on a real CP. And in fact, if you do that, you're going to find that the ECBs have a V in front of them in the work volume. If you copy a save all into a work volume, it copies the ECBs, even though there are no ECBs to be dealt with in a work volume. But it still puts them in there. And it just puts a V in front of them for virtual ECB, and they're all there. So makes it easy to do work on this. And then if you go back and this is interesting, when you take a thing out of a work volume and copy it back into a regular CP, at some point in there, Foxborough's smart enough to strip those V's back off, and it puts it back in as though they're just a regular ECB. So, welcome back. I think we all know where you've been, Marcel. It's not good. Anyway, so if we go on, this is like what it looks like. You go to the control configurator, and you notice there's a CIO volume configurator. This is what it looks like on my box. I have these available. You can make them where you just pick them off the menu there. It's pretty straightforward. So is there no downside at all? Well, there's a little bit of a downside of anything you do. There's no physical CP. There's almost no system loading or overhead. They're independent of the control system, but not quite. It still interacts with CSA. So if you put some blocks in your work volume, those names are now reserved in CSA, and you can't go stick them into a control processor. So that's a problem, okay? You can't do that. That's just a function of having the CSA in a unified namespace. We only get to have it in one spot, and you took a spot, so you don't get to put it somewhere else. You don't see these in Fox Select. So that also means that sometimes you forget that these things are in work volumes. They're hanging out, and you don't see them in there, and then you try to go build one, and it says, oh yeah, I got it in a work volume. You need to practice good system hygiene and discipline. System hygiene meaning clean up after yourself all the time. If you add your own volumes, which I said earlier that I do, without using sysdef to define them, and then you recommit them, they will disappear. And the stuff that was in them will still be in CSA, and you will not be able to easily get rid of it. Now, one of the really weird things is if you take those entries away, when you recommit, they don't really go away. It just takes the names out of the name stuff, so you can't find them anymore, and they're really still there. So if you put the name back and go back to that work volume, all of your stuff is still magically there, even though it was gone, which is really strange. So you got to be aware of that. And that's what I said. Those entries are in the CSA, and they're in the OpFox CIO config. They aren't gone. They're just not accessible at that point. So it looks like they're gone, but they're really still there. And so you fix them, you don't want that. You don't want that problem. You don't have to have that problem. The trick is don't recommit a box if you've like added them by hand. Not a big deal, but it's something that you can get burned with. The upside though, they are great for people that are wanting to learn to use ICC print and ICC driver task, because you're not working on a real control processor. So if you're wanting to play around and go, I want to go change some things with an ICC driver task, work volumes are the way to go. It is a great way for you to practice and get where you feel comfortable making those changes that you wouldn't want to make on a real CP, not one that's running your plant anyway. Okay. Okay. You don't want to learn ICC scripting on a real CP. I got that. The best thing would be a test bed with a real CP, and then, you know, or their subscription to the Foxborough Schneider's cloud-based setup. You know, then if you don't have that, then you want a real CP that's not a production CP, it's on your system. And then you go down the line, you get a work volume, and then you go just, you know, keep going. But, and if you're done with a project, you know, you can initialize a work volume and it's instantaneous. So let's say you built a bunch of blocks, you're testing it, you got them where you want them, you're finished. Unlike initializing a real CP, where if you initialize it, it takes some time, and then you got to reboot the CP. It says a reboot must occur, blah, blah, blah. You don't have to do that. You just go initialize, and they're gone. It's about that fast. It's very, very fast. So it works really well. So how do you load a volume? Well, it's so easy, even a co-op can do it. I wish I had one here. You can load a save all. If you don't already have those compound names in your system. If you do, it's going to say you have a duplicate compound name, and it's not going to let you load the save all in. So that becomes a bit of a problem, especially if you're trying to do some work on there. So this is how you do a load all. We all know that. Now you got copying compounds to the paste buffer. Well, this is the next way to put them in there. This works pretty well. It's going to ask for a new compound name, which is easy, unless you got 11 or 12 character names, and then that's a challenge, because sometimes you got to rename it something. And if they used all 12 characters, you got to decide which one of those 12 characters you want to change, or if you want to try to keep it the same, or you can rename it like, you know, A, which is not very descriptive. If it used to be, you know, utility CP1, and I renamed it A, I'm not going to remember that that's what that was. Stuff like that. And it can be time consuming if you have a lot of compounds. That's why it's easy for a co-op to do it. So if you do this, come in here and we're going to make template, right? And so we go, okay, we're going to copy template to the paste buffer. We got to give it a new name. You do that, and then you can paste it back. And here I have template X. I just copied the whole compound and put it in. So all of the blocks that were in template, all of them, whatever they were, just got copied and put into the work volume. Now you can copy back out of the work volume into a running CP. You have and you can copy one block, or you can copy a whole compound. You have the ability to do that. But when you paste them in the paste buffer, it makes it easy to move whole compounds. So work or library volumes, and that's another thing. You will sometimes see them referred to as library volumes. I've always referred to them as work volumes. Vol work is the default name for one of these things, but in the documentation that shows up a lot. So if you have a work or library volume, you have a place to put your toolkit, and that's a place where if you got a bunch of blocks that you use on a regular basis, put them over in a work volume, have a neat name for them that you like, and then anytime I need one of those blocks, I can just go build this. Especially like accumulators and stuff, where you have to remember that, like, if you got a half a second period, you got a meter factor that's like, you know, gallons per minute is this divided by this, and gallons per hour is this divided by this, and you know, furlongs per fortnight, which is a unit of measure that I think Sean is familiar with. Things like that, you have to use these big, you know, divide, you know, 2 weeks by however long a furlong is. I'm not sure on that one. But it makes it really handy for doing that kind of stuff. They're very easy to clean up. They're very lightweight. They allow you to do a lot of experimentation. And it's something that the kids, I hardly ever see anybody with anything in a work volume even if they are using ICC as their main, that's their configuration tool. It's very handy if you're still using ICC for configuration. If you're doing the same stuff with the control editor, you just wind up building a bunch of strategy templates that you never deploy. You put them out and kind of have them hanging out, not in a CP, and you can do the same kind of stuff. This was around forever, so it's very, very convenient. All right, any questions about that? Questions, comments, concerns? No? Yes?
If you've got multiple types of control power,
Yes.
library doesn't care.
Yes, I know.
So you've got 270s that you want to turn into 280s.
Yes.
Copy, in the workflow, set up your channel.
Yes. That's correct.
If you're bringing in blocks from integrators, both system stuff, same thing. You bring them in, do the changes that are necessary to go, for instance, from an integrated 30 SI, copy it back.
Yep.
Very useful.
It is very useful. It's very useful. It's handy, and like you said, and it does give you access to parameters that you don't have anywhere else if you don't have the right kind of processor to do it. Correct. So yeah, they're useful. They're good to have. All right. Well, I managed to get all the way up to 3 o'clock without even trying that hard, to be honest. And so it's time for us, which we would, at this point, my plan was, and our plan was, to have a round table for as long as we wanted, and then go to party foul at 5:30, which I asked a bunch of those questions earlier. So I guess the question I have for the group is, do we have things that we want to discuss? Does, anybody got anything at all? Price of Bitcoin, anything. Anything at all. What about, well, I think Marcel had the Wonderware OMI stuff. It was in his software roadmap where he talked about it. And David McCullough, do you remember what he said about OMI and their Wonderware stuff? You need a microphone because I can't hear you up here. Yeah, Mickey, I like that. Yeah. Go ahead, Roger.
David.
Maybe a little. But you.
Yeah, Bob's here somewhere. Bob, I know you got delayed with flights, but version 8.3, I think, comes out later this year. I wrote it down. The alarming is really kind of one of the weak points in Control HMI. They've made a bunch of changes to do with that. Not needing to use a console session for the alarm manager is the big one I wrote down. Updating the alarm panel. So a lot of that seems like Control HMI updates in version 8.3. No, 8.1, sorry. That's the one that's out recently.
One of y'all said y'all had the new new Pi software, the Viva Historian. Was it a difficult change, or did y'all just dump it and start over on your system?
Yeah, I will say Pi, even though Aviva bought them recently, I don't think there's much integration with Control HMI. It's purely the Wonderware Historian at this point.
Aviva Pi relative to Foxborough, we still use OPC to pass to Aviva Pi. That's where you're also at.
I've got to do something about it. So I'm just curious.
Yeah, we're getting ready to with Galloway. One thing I've harped on with Control HMI is it's Wonderware, right? So it can out of the box really. I mean, you need a license, but it can talk to PLCs, a lot of different PLCs. We do a ton with Rockwell PLCs, but I think at the Nationals Users Group a couple of years ago, somebody did Siemens PLCs, and it's before Foxborough there was Wonderware with PLCs. So I know a lot of the times we add an FDSI or potentially an FDC 280 just to like read a bunch of values. So if all you're really doing is reading values, then using DI objects is what they're called in there, and there's talk to Marcel, he'll tell you all about the licensing. I think we found that like for a medium-sized plant, the price of one FDSI is roughly equivalent to 20,000 tags in the DI objects. And it's easier to manage reads and writes because it's just writing to tags rather than, in an FDSI, you got to like set up some complicated scheme where if the panel view is writing to it, it's one thing. If you're writing to it, it's a different thing. Whereas using DI objects, it's just an HMI that can talk to Foxborough and the PLC at the same time. Somebody, who are you pointing to, Dave? Oh yeah, I don't think he needs to come up here in front of everybody and talk about it. I just pointed them to you if they had questions about the licensing for DI objects and device integration stuff. Or I could show you the email from Marcel if you'd rather come to me, but we asked Marcel, so.
So licensing IO points has made very easy introduction of the FCP 280 in 2014, right? We count IO points across the system, and we count them by analog, digital, and soft. And we count them for the whole system, and you license them for the whole system. So we get away from having to license per gateway, per processor, and within a gateway and processor per type. So we drastically simplified all this. And there's 3 different types of licenses, one for new purchases, so if you expand or if you buy a new system, and then one for upgrading existing licenses with a customer first maintenance agreement, and one for upgrading without. So the cheapest option is if you have a customer first maintenance agreement, whatever tier, whatever size, anyone qualifies. Even a 24-hour call-in type of super cheap contract qualifies for the bigger discount. And that's it. No, so if you're adding, that means new license. Upgrading means you have a previous license of whatever generation, whatever origin, whatever date, right? Can be a paper-based license from the 80s. This qualifies for an upgrade. So you replace something that exists with something current. If you extend or expand or add, it's a normal new purchase. If you upgrade and extend at the same time, we make it commercially 2 processes. So we do the upgrade as a separate process with a reduced price, and then we add the missing pieces to top off until you get the final amount as a new purchase. Does that answer the question?
That was a totally different question, but I didn't stop you because I was interested in that
Okay, so
answer.
please correct me then. What was the actual question?
I was specifically pointing them to you if they were interested in the device integration, the Wonderware drivers for.
Oh, the Wonderware. So we call them communication drivers these days. Yeah. So that's a different story. We qualified the professional version of AvivaCom drivers for the current system, starting at control software version 8 and 8.01, 8.1, and so on. The professional version is an unlimited license per server device. So it looks at whatever happens on this server, any number of protocols, any number of tags per protocol is covered with one license. And I believe it's like a lower 4-digit number. It's not really a big deal. That's it. So then what you do is you connect your system with the orchestra tags to some external data source or data sink, whatever. And then the Foxborough DCS translates those tags that are orchestra tags into compound block parameters that you eventually use in HMI or historize in a legacy historian. If you're on a current system with controlled software, it just directly shows on screens and in the Aviva historian. So, but the licensing is unlimited number of tags, whatever protocol you want to use, which is supported from the professional license. So it's the second highest license type that there is. The highest would be the enterprise license, but it brought features that we thought we would not need, and it was a little bit more expensive. So that's why. Is that the answer you were looking for?
Yes.
Good. Any more questions that we missed?
This is your chance, guys. Marcel's in the room.
We're still here tomorrow, right? So it's not the last chance. We even have dinner, guys.
Go ahead, Heather.
Our block tied to 2 separate SBM 204s. Has anybody ever done that?
AL redundant?
Yes. We're considering doing that. We need to know, is that a bad idea?
Roger, the only place I've been to that has done that. I know that, like, water valve on your boiler, I think, an AL redundant on that.
Yep. Trying to remember. Let me get you some details on that.
Okay.
It's using two
2 FBM 204s.
with the base with 2 different analog inputs coming into them.
Redundant outputs. Redundant
Outputs.
Yeah.
Okay. And feeding the
If
2
you
out.
have one FBM die, you got the other that's running in sync with.
I'll get you an answer. I'll give you an example. Screenshot.
So apparently they haven't had any problems.
Yeah. I hadn't been working on it for the last 2 weeks, so.
I got a question that might be better for Liz. I don't know. Looking for a way to, if there's a way to identify like unused FDF files, like a 5S my system. It's easy to recognize the ones that you're familiar with, but there's a crap ton of the old screen files.
Probably just a possibility for unused FDF files.
Yeah.
Unused, you mean like nobody's using it? Or
Yeah. Haven't been opened in, I don't know, a year.
Windows script, there is a directory in last day. I don't know exactly what the script would be. I think it is.
You're saying, you said there's a last ref file somewhere for Foxview?
The directory entries in Windows, they got an entry when it was created, when it was modified, when it was last reference, last one.
But I have to look at what was not.
Yeah.
Go back and look at how many times that restraint, you know, has to be. Go back and look how many times that restraint.
That's my fuck truck.
Yeah, like that.
Fox truck can keep this. I'm talking about the videos, record and stuff.
Yep, it's after lunch.
Ever dealt with this issue, but my site has virtual machines, so we have hosts or we have servers underneath it, and when we do quarterly Windows patches updates, we have to reboot the computers. On occasion, there are some servers that have like the splitting, blue wheel that's saying I'm waiting for I think it's like a group policy to be applied to it, and unfortunately, those might take 4 hours to load up. I've talked with TAC at Schneider. We've tried a bunch of things, haven't found a solution. It's very sporadic. It doesn't happen consistently. I don't know if anyone's dealt with that specifically here.
I've had them take an hour, but not more.
An hour
Yeah.
after patches, or
So the only thing that we've done that have gotten it moved along is taking the server out of the ACN network, which whatever is trying to push it down, the group policy stops, and that's able to load it quicker. I would put it back on the network whenever I see a period of time where it's okay for us to put it back on and let it spin and do its thing before it pops back up.
what happens when you connect it later?
Sometimes it spins again like 4 hours, and then everything's loaded up. Sometimes it does it right away. Very sporadic, and there's everything that I've gone over with the TAC team. They're not sure what's going on. So
You're not the one that's asking about that on the list at the moment, right?
I might be. I don't know.
Sounds familiar.
For those of you that do patch your servers, are you using something to help push that patch onto them? Or are you just walking to each individual machine, workstation, server, doing them one by one? Manually?
You can push it. You can push them to the machine, but you have to go to that machine to pick it up.
We don't typically patch, we're isolated from any vulnerability because we have data diode and all that. The IT is asking possibility of storing it.
I know.
Day.
Oh yeah, like forever.
I think Marcel, there was a future patch management bullet item for rapid deployment, right? Am I remembering that right?
So did I understand right? The question is about a future patch management in the context of rapid deployment?
I mean, present would be better, but I think I
Yeah.
remember you said it was a future.
So our current patch management solution is planned to be part of a phase 3 of rapid deployment. This would include patches from third parties and from ourselves, so quick fixes, GDs, MPs, and Microsoft and other parties' patches. For Microsoft patches, we're currently using WSUS, Windows Server Update Services, but this is about to be deprecated in a future Windows version. So I'm currently actually not aware about what will be the solution that we will commit to, but we look at a holistic offer that helps with everything, right? Not only our patches, but also Microsoft and third-party patches. So it's currently in the works, and I don't know the exact answer of it. And I don't even know if it's part of rapid deployment. This is one of the several options we're having. So I would like to say we are aware of this, and we don't know yet what exactly will be the solution.
But WSUS currently today is not.
Today is that's the offer of choice. We do have a product that actually employs this called DCS Advisor, formerly known as Remote Watch. It's an optional component of a customer first service level agreement. It technically is a server that we prepare and put on your site. And the server is the central point of getting data probes from your system, enabling us to prepare early warnings for things that potentially go wrong, and also to be the master for updates and patches for the system it's assigned to. And it's managed by us and owned by us, and we charge you as part of the customer first service agreement for a small fee for this feature.
For Windows update, and I've also gotten emails where I have a hard drive that's full and I need to address it. Yeah.
Positive feedback. Thank you. Keep it coming.
Brian, you said you just had issues getting approval from IT.
They put our name, log on our computer, it's like, hey, he would log on this server on this day for this moment. Access to those, they would access to those.
They might want to look at it again, because I know they just changed recently from one provider to one platform to another. I can't remember the name.
From next
Next
nine
slide.
to a new one. Yep.
So that was
Yeah.
DCS Advisor / Remote Watch is the old name.
Yes. And it is a customer first offer, right? So the right people to work with is your customer first service representative. So an existing contract is the prerequisite, and then this is an optional element. What was your question again? So iBatch is now called Batch Management for System Platform by Aviva, right? So we have qualified the latest version from Aviva for System Platform 2023 with the version 8.01 and Control Core Services 8.98. The product is very stable. They essentially keep it up to date with cybersecurity concerns. They are preparing CRA compliance for their products as well, and badge management is part of this. They claim that with the 2026 version to be announced end of this year, they will be the first version that is compliant. And we have to see what is the impact on a Foxborough DCS, right? In a nutshell, having a CRA compliant software means it's all encrypted and authenticated, as I tried to express earlier, which usually breaks communications, right? So we have done early experiments, not with Batch, but with the System Platform 26 version, and it broke everything. And we use for controlled software the system platform to communicate between the engineering environment and the CP hosts when we deploy things, or to deploy from the Galaxy to the operator screens, HMI windows, or we use it to do real-time communications between CPs and between CPs and workstations. And all of this is encrypted, so it doesn't work with the existing system without having us modifying some things that make us work again. So this is part of the project we do with the upcoming control software, control core service releases to make sure that the whole system is CR compliant and works again. But when your question is about the core features of the batch product itself, I would say it's 99% stable. And there's no plans to change that. So the product is very mature. As you know, it's also very, very old, right? It has been created by a third-party company called Soft Systems, and that was bought by Wonderware, and then Wonderware has been acquired by Invensys, and now this is part of Schneider, and it's still the same product from these days. Right, right. And it's still pretty powerful, right? The whole execution model with the recipes that are generic and that translates into working recipes with train booking and things. This is pretty advanced. So we don't see a big need to improve that.
Anyone else? All right. Well,
Let everybody go to the window, and then at 5:30, and dinner tonight at Hotel, which is 2 miles, 2.5 miles from here, like I said earlier. And hotel shuttle will be driving people over at 5:30, and